Mars, what it looks like 21 years after the last spacecraft successfully landed and sent back pictures. It has been a long time between snapshots. The color images show a wealth of rocks and boulders, hills, perhaps mountains off in the distance. A geologist's field of dreams. As the images came in, cheers of joy rose from the Pathfinder control room. One of the many moments of exhilaration for the space agency.
What better present can this agency give the nation on its birthday than this landing on Mars? It's just terrific.
So much had gone so well. All the engineers and scientists had expected glitches. But from the moment the vehicle began its descent to the Martian surface, milestones came and went more smoothly than anyone expected.
To imagine we would see the signal right after we landed, to know that the spacecraft was healthy after all of that, and then, of course, to have it come up right on target with the low gain, and then even more spectacularly, to come up right on target with the high gain, pointing within a degree of the Earth. Unbelievable.
There was no lack of emotion at NASA's Jet Propulsion Laboratory. Even the Vice President called to congratulate the space agency team.
And congratulations on doing an absolutely outstanding job.
But perfection would have been too much to expect. The first black and white images showed the airbags, which allowed the vehicle to land so safely, had not retracted completely under the pedal on which the Sojourner rover sat. After testing a plan in a place called the Sandbox, engineers sent commands to the vehicle for the pedal to raise up and the airbags to be pulled in further and the rover ramp to unfold. But the flight team won't know for several hours whether the final command was carried out.
Looks like we will not receive that data in the last transmit session, but I would like to congratulate all of you on a job very well done.
It will likely be late in the day on Saturday before the engineers can get the Sojourner rover off of the Pathfinder lander. The engineering team has managed to save some of the drama for the second day on Mars. John Zarella, CNN at the Jet Propulsion Laboratory in Pasadena, California.
Just about 1 hour from now, NASA officials are expected to hold a news conference on the latest details of the Mars Pathfinder mission. We're going to bring that to you live when it happens.
Und wir bleiben gleich im All. Die US-Sonde Pathfinder sorgt für eine Sensation nach der anderen. Nach der gestrigen spektakulären Landung auf dem Mars funkte sie in der Nacht erste sensationelle Bilder auf die Erde. Jetzt versuchen die Forscher, das Marsmobil Sojourner flott zu machen, das die nähere Umgebung erkunden soll. Ein Luftkissen hatte das Fahrzeug nach der holprigen Landung blockiert. Vom NASA-Kontrollzentrum im kalifornischen Pasadena berichtet Christoph Lang.
Grauhaarige NASA-Wissenschaftler feierten die geglückte Landung so ausgelassen wie kleine Kinder. Dann schickte die Sonde die ersten Farbbilder vom Mars ins Kontrollzentrum im kalifornischen Pasadena. Sie zeigten der Welt, dass der Pathfinder an einer günstigen Stelle niedergegangen war. Und Missionsmanager Rob Manning hatte seinen nächsten Glücksmoment.
Oh man, that's a good picture.
Die Aufnahmen bestätigen, dass die Sonde in einer steinigen Ebene steht. Sie landete stabil auf ihrer Unterseite, wie es sein sollte. Das Marsmobil auf ihr ist noch zusammengefaltet. Und offenbar hat alles den Abwurf, der von gewaltigen Luftsäcken abgefedert wurde, gut überstanden. Es läuft genauso, wie wir es immer wieder geplant hatten. Bis jetzt ist die Mission fast traumhaft perfekt. Als nächstes soll das Marsmobil, der Sojourner, sich in Bewegung setzen. Hier gab es eine kleine Klippe. Einer der Luftsäcke hatte sich verklemmt und die Rampe blockiert. Doch dann gelang es doch noch, ihn aus dem Weg zu schaffen, wie dieses Bild beweist.
Das ist ein sehr großer Moment, nicht nur für uns, sondern für die Raumfahrt in den USA, aber auch in Europa, glaube ich.
Sagt Horst-Uwe Keller vom Deutschen Max-Planck-Institut, das Kameras und Sensoren für die Mission mitentwickelt hat. Die nächsten Tage werden eine Flut von Bildern der Marsoberfläche bringen. Die Wissenschaftler wollen herausfinden, ob das Landegebiet tatsächlich einmal von Wasser bedeckt war, wie sie glauben. Denn wo Wasser war, könnte auch mal Leben gewesen sein.
Christoph Lang in Pasadena. Die Fahrt des Marsmobils ist aufgrund von Computerproblemen verschoben worden, wie es heißt. Hat man die inzwischen im Griff?
Nein, im Moment leider noch nicht. Das Problem ist, dass auf dem kleinen Marsmobil ein Computermodem nicht angesprungen ist. Und das hat zur Folge, dass zwischen dem Marsmobil und der Muttersonde die Verbindung derzeit beeinträchtigt ist. Beides sieht man ja im Modell hier hinter mir. Die Experten sind relativ zuversichtlich, dass sie das hinbekommen, haben ihre Arbeiten aber im Moment einstellen müssen, denn auf dem Mars ist es Nacht geworden und da arbeiten die Solarzellen natürlich nicht. Mit anderen Worten, man hat keinen Strom im Moment. Wenn sie es nicht hinbekommen, dann könnte man immer noch das kleine Marsmobil von der Erde aus steuern, allerdings nur sehr eingeschränkt. Das wäre dann schon ein Rückschlag. Aber wie gesagt, momentan ist noch längst nicht aller Tage Abend.
Wenn er denn funktioniert, wie lange kann der Mars Rover denn überhaupt in Betrieb gehalten werden?
Also mindestens einen Monat lang, sagen die NASA-Experten. Aber sie sind inzwischen zuversichtlich, dass es auch sehr viel länger sein kann, mehrere Monate. Also aber im Moment ist die Priorität, man muss diese Computerprobleme in den Griff bekommen. Alles andere kommt später.
Dankeschön, Christoph Lang nach Pasadena.
From CNN International, this is World News with Jim Clancy from CNN Center.
Hello and welcome to our program. A journey to the red planet offers Earthlings a view of new horizons, but it's not all happy trails for Pathfinder. Yes. Pictures of the dramatic Martian landscape have been beamed back to Earth as part of the U.S. Pathfinder mission. Scientists of the American Space Agency, NASA, say they are pleased with the transmissions that they have received, but there's a glitch that now casts in doubt how much detailed information they'll be able to record. For more on the story, we're going to go now live to Pasadena, California, and a press conference with scientists at the Jet Propulsion Laboratory.
On the planet seem to be watching and enjoying the moment with us as we went through the incredible events of yesterday, and of course capped off with the wonderful pictures that we saw. Well, we've got a busy day today, and we're going to give you a preview of what's ahead. At 10:08 this morning, Pacific Daylight Time, Earth will rise over the landing site on Mars. At about 1:19 this afternoon, the sun will rise over our landing site in Ares Vallis. What the team is up to this morning is we've prepared, over the night actually, we've prepared sequences for a number of activities today. I think you heard last night that we don't believe we've deployed the rover ramps or had the rover stand up. We don't know that yet. We'll be taking some actions this morning to determine that. The reason for that is when we were commanding yesterday, the Earth was very low on the horizon. The antenna was basically looking low on the horizon and looking through other parts of the spacecraft, basically through the camera. And we do not necessarily expect those signals to have gotten in. We also had a downlink session last night around 9:30 in which we did not receive any data. And again, that was reported last night. And again, that was not unexpected because of the very low position of the Earth and the blockage of the antenna by the spacecraft. So at 1 o'clock this afternoon, we will be commanding the spacecraft. We need to talk to it this morning, let it know that we're here waiting for it to wake up, and or we will basically wake up the spacecraft, that we're ready for today's activities. We have a couple of things we're going to command the rover to do at the same time. And we'll just get a very brief signal back from the lander that it received those commands. So this is just, we'll send up some commands and it'll signal back, it'll turn on its transmitter for just a couple of minutes to say, I heard you, I understand you, we're going to go off, I'm going to go off and execute those commands. But we won't know, in fact, that it's done all those things until 3:20 this afternoon when we receive our first regular communication cycle. We'll be getting telemetry down from the spacecraft. It will give us the spacecraft health, tell us how it did last night, did it sleep well, have any nice dreams. I'm sure it's having a wonderful time sleeping, as some of us got a little sleep last night. If everything looks good in that telemetry, well, I'm sure it will look good. At 5:58, we will have sent a command to execute the ramp deploy and the rover stand up again. Since we don't know whether it's happened, we would know if it had happened at the 3:20 downlink. Assuming it did not happen, we will send that command again. And that's to deploy the forward ramp and have the rover stand up. And again, the spacecraft will respond with a short semaphore saying, we understand the command and I'm going off and executing it. The real excitement then starts a little later at 6:28 when we should get back our images of the rover ramps deployed. Rover ramp, just one ramp right now, deployed onto the surface of Mars. And some additional images will also come down at that time at 6:28. Depending on what we see there, if it looks safe to deploy the rover, if the ramps are in a good orientation, that there's a good place for the rover to drive off to, we'll make the decision to deploy the rover as early as about 7:40 this evening. And then about 9:58 or 10 o'clock, we should receive back images of the rover on the surface of Mars. Now, again, all that's contingent on an issue we have with rover communications. Right now, Jake will go into this in a lot more detail, but let me just say that we have a condition in which communication between the rover and the lander is degraded. We're hearing each other, but we're just kind of getting one syllable across the net. We're not getting full sentences. We're really not able to communicate. So we're kind of in a degraded mode. The rover team worked very hard last night to look at various options. What can we do? There's a lot of things that we can do to fix these things. It's amazing what you can do from 120 million miles away, as of course the Galileo team demonstrated so incredibly with the unfortunate high gain deployment problem there. But obviously, I'm confident, I think our team's very confident, we'll get to the bottom of this problem and we'll get the rover off hopefully sometime later today. Thank you. My esteemed colleague, Dr. Peterson.
Yesterday, I described the experience of flying economy class to Mars and showed the first views of the Martian landscape. Today, I'm able to extend that view and to show the original view in a little different fashion. Every day now, with the help of the IMP science team, the project engineers, and the image processing lab, we will be revealing more and more sophisticated views and interpretations of the neighboring planet and the wonderful place in which we've landed on that planet. If I can have the first view graph, or the first slide, I want to show you where we think we are on Mars. Now this is, oh, I don't have this monitor on.
There you go.
Okay, we think we're up here. And notice how close we came to a rather large crater. Very close. Like having a little trouble seeing the monitor, but...
Looks like they cycled. Well, that's actually one of the reporters just tried to turn it on. Skip, this monitor's not working.
But where these lines come together is where we think we are. And the lines are showing objects that are significantly above the local terrain so that we hope to see these objects on the horizon or nearby. So the first thing we've all noticed yesterday in the pictures is a little bit of a hill right behind the rover, and that's this little knob over here to the left. And in the distance in that frame, although it was probably hard to see and maybe impossible to see, but we have seen it up in the science area, we can actually see this large feature way in the distance. Now this is 20 miles away. And of course, since the atmosphere opacity is more than we thought, we can actually see the haze influence between us and this distant mountain. So over the next few days, we'll be showing some close-ups of what it looks like to see a distant peak of this sort. But first, let's show the pictures yesterday in a little different fashion. And if I can have the video. The first video shows the scene that was presented yesterday. And now we are scanning from left to right. And this is now a more sophisticated way, of course, to look at the images. And we can see that hill in the background, which is actually sort of a Twin Peaks there, little saddle. And now we see a geometrically rectified scene where the rover doesn't have the banana shape that it did in the pictures yesterday. Now, everything is straight lines there, and this is a more correct representation of what we're actually seeing in the landscape. Okay, let's go to the first still, and that's the same picture. The next picture, please. Well, the next picture is that one that's the, there it is. The rover now geometrically rectified so it doesn't look distorted as it did yesterday. And there's a few things I'd like to point out to try and encourage your thinking about what this landscape might be, just as we're encouraging our own thinking. One is this interesting group of rocks here. If you may have noticed, or you may not have, that they all seem to be slanted, kind of in a northwesterly direction. This rock here, this rock here, this one, and this one, they're all kind of leaning towards the northwest. Now, if you remember from the introductory remarks in the last few days, we're in a floodplain channel, and the floodplain is flowing from south to north. Could these rocks be oriented that direction because of the influence of that last flood? This is a question that is being asked up in the science area. Now, of course, I don't know the answer, but just to help you think about the picture. We also see, if you look closely, that the soil is not all the same color, that there's areas that are more brightly colored and areas that are darkly colored. So there's definitely two different types of soil here. That may be that some of the soil is brought in by a wind process and dropped onto this scene and therefore isn't really native to this area, or it may be for some other reason. But in any case, we also see a few different areas that seem to be a little bit redder, and they're somewhere in this area here. These are areas we hope to send the rover over the next week or so. And we're also looking at a couple of rocks as places for the rover to visit once she gets off her pedal. And one is this rock here, and we're going to take some close-up views, I believe, tomorrow of this rock with all of our filters and try and make a scientific assessment. And the other rock we find interesting is this sort of tabletop rock over in this direction. So these are the things we're thinking about in this picture. We know now that this hill is not a crater, that it's just a small knob that would show up in the Viking picture as a little bump. That's not, even though it looks kind of like a crater rim, it's not a crater. Now let's take a look at a new view. Turning to the south, unfortunately we have no color imagery yet. This is the red filter. It's compressed 12:1. This is what looks to me like a Viking scene. It's kind of flat, lots of rocks, but small rocks. This close one is not all that high, really, because we're down so low, it makes it look a little high. Now, these breaks in some of the lines here are caused by parallax. That target is just right close to the camera, and as we turn our head, as you would turn your head looking at your finger or some other close-by object, it moves against the background. So it's very hard for us to line up the close-by objects. And down here, you can see where the azimuth mast is. This is taken early yesterday, and therefore before they deployed. But now let's look at, this is, by the way, if I didn't mention, towards the south, and this is the rim of that big crater that I showed in the first picture. Several kilometers across, that's just the edge of it. And if you look very closely in this picture, there's a little bump on the horizon. We think that's way in the distance, one of those knobs that the line in the first slide was pointing to.
How far in the distance is that crater?
Oh, 3-4 kilometers. And unfortunately, the low-gain antenna, which is this object right here, hides the rest of the crater. So even if we showed the rest of that picture, you wouldn't see anything. But as soon as we deploy, we'll look over that low-gain mast, and we'll be able to see a very nice view of this crater. So this is something to look forward to when we deploy our camera at the end of the day. Right, Brian?
Yeah. Whenever you decide you want to deploy it there. Yeah, we would normally deploy it after we complete the set of images coming down around 6:30.
Okay, now we've looked to this is pretty much a view to the south. Let's turn around and look more towards the north in the next slide. Now the picture, those are the first picture I showed sort of ended right here, and now we have some additional information that I can show, and this big rock, which is, I'm just guessing because we don't have stereoscopic views yet, but I think it's at least 1 meter in height. It's probably as high as the camera is because you can see it's lined up on the horizon. We came very close to that rock. Now, if we're landing with thrusters and landed on a rock of that sort, we would be in real trouble. So the airbags, again, have worked really admirably. We again see the scrape marks where the airbags were retracted. Some of us think we can see additional scrape marks from when the airbags were re-retracted. And this is a rock we're quite interested in from its color properties. I don't have a slide to show that, but I will soon. But the most mysterious thing in this picture is this little object on the horizon that has been likened to a couch. Somebody suggested there was a homeless person camped out there. But I thought it might be the parachute. Brian thinks the parachute is brightly colored, and that couldn't be the parachute, and therefore the geologist, of course, immediately thought it was an interesting rock feature. But this is definitely something we're going to be looking at, and as we're allowed to change our sequences after deployment, we're going to look at that feature with all our color filters and try and see if it's different in color from the other rocks. So that's what I have to show today, and the rest of the day will be spent finishing the nominal Sol-1 sequences that we were not able to complete yesterday. And we have to finish those before we can deploy because we have what we call our insurance pan in there just in case something happens on deployment, which is actually a very violent activity. Our longerons, that you can see in the model on the left, are thin fiberglass rods built by Able Engineering, and they are coiled down into the base canister, held down by a pin. When we pull that pin, this thing springs up and actually has enough rotational force to coil itself back down again and come up several times. So it's quite a violent operation as we deploy the camera, and that's why we want to have an insurance pan, which is some 280 megabits of data taken around and around. And if something happens, we'll have a tremendous wealth of data to draw from over the next few weeks. It would take weeks to get all that back. So we want to be sure we have that stored in the memory before we deploy. And after we deploy, we're not so much interested in what's in that memory. We're going to take new pictures. So that's happening today. We're measuring the opacity of the atmosphere. We think the dust is thicker than was first thought. It's really quite dusty, and we're going to be studying that dust. Could it have something to do with the dust storm? Well, I really don't know, but it is particularly dusty. We're going to take a close-up view of the soils and down there where they're disturbed, and this will be our 12 filters, lossless. This is our best view of those soils. That'll happen today, and we're going to complete our 360-degree view, and I'll be able to show you that. The one section that remains will be shown at as soon as we get the data and can process it. So with that, I'll turn the microphone over to Jake to talk about the rover.
Hi. Yes, let me briefly recap the situation that took place yesterday. We had, as you know, we had performed our pedal motion airbag retraction activities yesterday to give us a better chance of being able to correct a problem of airbag drapes over the rover ramps. One of the things we'll try to do today is to send the commands up to deploy those, at least the front ramp, and get some additional imaging of the rear ramp area so that we may even be able to deploy the rear ramp sometime later today. That will be, that will also accompany that will be the actual release of the rover tie-downs. There's 3 tie-downs, one on each side of the vehicle, and a tie-down of the APXS. And that will prepare the rover for stand-up and deployment to the surface. The communication problem, which is the one that we worked late yesterday and overnight, manifested itself as a lack of communication between the complete communication between the rover and the lander. We have indications from some of the lander telemetry that indeed the rover has been mightily attempting to send information to the lander to send back down to Earth, and only the shortest frames of information in those communication sessions have apparently been getting through. We are in a position where we can actually request additional diagnostic data that was collected by the lander during the course of yesterday's activities to help us in attempting to isolate what this problem would manifest itself, how it manifests itself during the day. The other things that we did last night as part of the actual nominal execution of activities both on the lander and the rover were that the lander modem was power cycled several times during the night. The rover power cycled its communication system every hour overnight. It actually did a full shutdown every hour overnight. And we had some thoughts that this combination of power cycling would be one means of being able to correct what appears to be something like a synchronization problem or other related cause for this absence of communication between the complete communication between the rover and the lander. Now that information will be the diagnostic information will be available as well as any telemetry that actually did get through from the rover to the lander during the 3:30 to 4:30 downlink, 3:20 to 4:30 downlink this afternoon. Prior to that, we'll also try two other things to help us in diagnosing this particular problem. On the lander modem side, we actually have a redundant power converter that supplies power to the lander's modem. We'll attempt to use that and repeat some communication attempts prior to this actual downlink activity. And also we are going to attempt to send a short command sequence to the rover this morning and see if that gets through. The short command sequence will basically just reset a couple of parameters, and if it gets through, it'll give us some additional information about what portions of the communication link between the rover and the lander are still functioning and functioning well. But through an analysis of that, of the results of those commands and the analysis of the diagnostic data that we will receive from the lander, we may have some better information and some better insight as to what to try next to ensure that we can reestablish solid communications between the rover and the lander. Again, in all likelihood, some of the things that are already taken place over the course of the last several hours may have already corrected this problem, but we will not know that until later today. And Brian already went through the sequence of events if all the rest of this activity goes well, in particular if we do reestablish communications, and that would include deploying the rover to the surface of Mars sometime later this evening. And that's a good place to stop.
I'd just like to add a couple more things. In response to the request of one of the reporters yesterday, we will up the data rate just to get down more images for you. We'll be effectively doubling the data rate to about 4740 bits per second, starting with our 320 downlink. In addition, we'll be doing some more science observations. We'll be imaging the magnets. We'll be looking into the atmosphere for dust, and we'll be looking at the windsocks, see what the wind conditions are. So keep that camera busy. So that's all we have.
Okay, we'll go to Q&A here. Let's get a microphone down here in front to Bruce Smith.
Bruce Smith, Aviation Week. The fact that you're just getting the shorter frames in, what does that tell you? I mean, what do you suspect? Or does that narrow down the problem somewhat?
Yes, what we've seen evidence of is that the shortest frames of information have been getting through from the rover to the lander, and that's indicative of a degraded communication link, not an absent communication link. And what we'd like to confirm is at least that of the things we saw yesterday in the telemetry from the lander, that these were primarily associated with activities of the rover's initiation. That is, the rover sending data to the lander or requesting data from the lander. Now, we'd like to check one other communication session that is part of our communication link, and that is the ability to be able to command the rover. We had not done that yesterday. If you recall, the sequences we tried to send up late last night probably did not reach the lander and were not executed. So we'd like to do this short sequence as another test to gather additional information about the nature of that link.
Todd?
Todd Halverson of Florida Today for Brian. I'm wondering if you will deploy the rover before the communications problem has been resolved. And if you do give a go-ahead for the deployment at 7:40 p.m., give me an idea of how long it takes to actually get on the ground.
Well, let me say that if we still have this communication problem, we probably can't. We don't know whether it's a one-way or a two-way communication problem. We don't know whether, in fact, we can command the rover. And we'll learn that later today. We don't really have any way to... If we can't command the rover, then obviously we can't deploy it, because it has to stand up on its own. We can release it, but then it can't. It has to drive its wheels together in order to stand up. And so that takes action on the lander's part and on the rover's part. So we need to get this.
Brian Muirhead, who's one of the project managers for the Mars Pathfinder, just giving reporters some bad news. If we can't command the rover, we can't get it to move. This could be a big problem. They don't know whether it's solved or not because of the difference between the light on Mars powering the solar panels and when the rover area on Mars is connected to planet Earth. We got some new pictures. They enhanced some of the pictures they took overnight, and now we know precisely where the Mars Pathfinder is located on the Martian surface. But the headline in all this from Brian Muirhead, the project science manager, is that the rover is at this point stuck there on the Pathfinder lander. It's got its own cameras, as Jim Hill showed us earlier today. And the big goal of this is to get that thing off the Pathfinder, out on the surface of Mars, going around to rocks, sniffing them, finding out what they're made of, and showing us some more of the fabulous pictures like those we have seen in the past 11 hours. We'll take a quick break. We'll come back and talk about more of this and show you the latest pictures with a little explanation. CNN's coverage of the Mars Pathfinder landing continues.
What a day. What a night. What a time to be alive on planet Earth. We sent something to planet Mars today. It is sending back fabulous black and white and color pictures to the Earth. The folks at the Jet Propulsion Laboratory in Pasadena, California, put the project together. And everything has been going swimmingly until about 30 minutes ago, when some of the first pictures that came back showed us something that could be a problem. Maybe not a big problem, we don't know yet. But one of the things that is unique about this mission to planet Mars is that rather than landing on the planet, like most spaceships from Earth do, this one bounced into the side of the planet inside a giant beach ball made up of dozens of individual airbags. What was supposed to happen when the Pathfinder landed on Mars was that these airbags were supposed to retract underneath the Pathfinder and sort of look like that tannish mush that you see there below the solar panels on your screen in this animation. That's not precisely what happened. And as a result, what you just saw in the animation is not going to happen tonight. This is a picture that came down from Mars just a few minutes ago. Instead of being underneath and out of the way of the Sojourner rover, you can see that big tannish airbag is blocking the exit from the Pathfinder of the rover. And it looks like it's even possible that a piece of that airbag might be somehow connected to the ramp. The things that looked like rolled up duffel bags are in fact the ramps that Sojourner will use. This is what NASA wants to do to fix this problem. Even though all three solar panels, which are called petals, like flower petals, were flat and parallel to the ground, the one where the airbags aren't fully retracted will be raised to a 45-degree angle. And then the automatic retraction system for the airbags will be told to come back on and retract those airbags some more. If it works, the airbags will be sucked in as if vacuumed up underneath the Pathfinder, and then that pedal with the rover on it will lower itself again back down to a level that's parallel to the ground. The two ramps on either side will roll out, and then the rover will go out and do its job. It was hoped that that would all happen about 88 minutes from now, but that's not going to be possible because of the problem with the airbags. They're still scratching their heads in mission control, trying to figure out exactly the best way to do this. And so
That's going to delay the first movement out on the surface of Mars of that rover. My colleague John Zarella has been doing yeoman's work for the past 6-7 days out there at the Jet Propulsion Lab. Oh, buddy, you must be tired at the end of this long day, but isn't it satisfying?
I'm telling you, John, even standing up for 6 or 7 hours today, it doesn't seem to bother me at all. This has been quite an adventure tonight. Isn't it a shame that the only pedal that these airbags happen to be in a bad position on is the pedal that is containing the Sojourner rover on it. So that was a bit of bad luck, but after so much sensational, absolute near perfection all day, it is certainly something that's an acceptable problem that they will, I'm sure, deal with. They're going through the motions now to try and figure out exactly how they're going to handle this and get that airbag retracted so that they can get Sojourner off. And as you said, it'll probably be tomorrow. And joining us here tonight is Story Musgrave. And Story, you haven't been to Mars yet, but an astronaut for many, many years. You've flown in space probably as much, if not more, than just about anybody out there. And what was your feeling as you were seeing these pictures of Mars? I know that every astronaut would love to be the first to put his or her foot down on the red planet.
Well, I've dreamed. My imagination has taken me out there, John. The call is there. It beckons. The beauty of the place, it really does call. And with a brand new technology, with a very efficient small satellite that it came just scooting and screaming out in there, and it's there, it lets you know how doable the whole thing is. But it's like a stepping stone. We go from Earth to Mars, and away we go.
What did you think as you saw those first pictures? The black and whites came out first and gave us some really tremendous images. There's some there we can take a look at right there, what that looked like. Those were the first black and white several hours ago now. What were you thinking when you were seeing those?
It's just stunning, and you flash back to Viking, and you think of, we've returned to an old friend after 20 years. But the call is there. I mean, you just see it and you feel the pull.
Are you amazed at the clarity of the images and exactly the nature of the landscape? It seems to be quite a bit, and that's a rover wheel that we're seeing in that picture. But the landscape seems to be quite a bit different than what we saw on the Viking missions.
Bigger rocks, but still friendly. Still an incredibly friendly place. We just need a little bit of water.
And that's probably buried beneath the surface in permafrost.
Find out where the water went.
So these first exploratory missions that we're doing, any doubt in your mind, you say the call is there.
The call is there.
Any doubt in your mind when we see things like this after 21 years now that it's going to re-energize an effort to send humans to Mars, do you think?
No doubt. And the visual data is extraordinarily important. The scientific data is too. The spectrometry data will be incredibly important.
Here's the sandbox. Now look, we're actually seeing them doing the test to see if at how steep an angle they can get the rover off of one of the pedals. And that would be a rover coming down the pedal and into the sand, and they're... Now, a lot of these kinds of things are not foreign to you, certainly, because they did many of these things within the human space program.
That's testing that simulation, and that's a playground. And it's incredibly useful to not theorize as to how things are going, but to go out there and to mimic and to set up the scenario and to run it for real.
Now, in a more, certainly a situation that was far more potentially dangerous, that's what they did during Apollo 13. They ran simulations.
Yes.
How could they get things fixed? So they're basically, here we are many years later, but doing similar things.
If the fidelity of your training and your simulation devices are good enough, when you need to test how it's going to go up there, you can do it on the ground.
Let's take another look at some of the black and white photographs that we have earlier today. Oh, we're back in the sandbox, so they are still. They're really looking now at, from what I understand, the angles, so that they can see that how much of an angle is going to be too much of an angle to get the Sojourner off, if that's what they end up with, a real steep angle once they bring the airbag in. So I assume that's what they're working with, to see how much they can have to play with. Is that what it appears to you?
I'm not an expert in that area.
This is what I had heard earlier from one of the engineers, that they were really concerned about what the angle might be once the airbags were retracted, if the pedal actually went down many more degrees than it is now. That would present a much more steeper angle when they unfurl the pedal there. So again, they're still playing in the sandbox, as you said, and trying to figure out the best. This could go for quite a while, I would assume.
NASA engineers at the Jet Propulsion Laboratory getting very excited about the fact that they were able to do something they have been working on, most of them, for more than 5 years. That is taking a $100 million, just a little bit bigger than a shoebox-sized rover, and plant it successfully on the surface of planet Mars. What a moment for these people. This is the live picture in Mission Control now. They have had a long day. It is 7:44 in the evening at the Jet Propulsion Laboratory in California, and they have been there putting in a very full day, controlling this mission from the ground, but mostly, based on what we've been told, just letting the Pathfinder do its own thing. It has a computer on board that has been doing everything just like clockwork. One little problem. CNN's John Zarella joins us from the Jet Propulsion Laboratory to talk about that and what kind of day this has been. John?
Well, I tell you, John, that, I think back it was December 4th when they lifted off from the Kennedy Space Center very early in the morning, a rather chilly night even for Florida back then. And here they are 6 months later to the day, and they're on Mars. And I remember interviewing Brian Muirhead, who's the deputy project manager, in the clean room a month before that, wearing our white bunny suits, and Brian saying, nobody would have given us half a chance of getting as far as we are today, and that was just getting to the clean room. And here they are now on Mars. We've had fabulous black and white images. We've had fabulous color images back from the red planet, and they've run into the one snag that they've got to work around. And there are those black and white images. And Story Musgrave, you're with us here, and we were talking about how that's an airbag there in the foreground. We were talking about how these things are tested and retested, and how now when they run into a problem, they'll go into the simulator to figure out. And you did that with the Hubble repair mission. You had to do tremendous simulations, didn't you?
It's basically play with physical things, as opposed to speculate and guess. And that's what they're up to.
These, you were saying, now there are a lot of rocks there, but again, that's quite a bit more in the way of what I thought. I didn't think there would be as many of the large boulders that there appear to be, and in the distance hills, and it's a different topography.
You have to ask them, but maybe they didn't guess to have quite that much in the water outflow.
And there's what appears to be one of those hills in the distance. And again, this is supposed to be an ancient river, an ancient outflow where a tremendous flood eons ago swept down through here, left and deposited rocks and all kinds of goodies for the geologists to get a look at. So it really is critical, isn't it, that they get Pathfinder's Sojourner robot off of the vehicle so they can start getting up to rocks like that and putting and studying them.
And doing the soil itself.
And the soil itself.
The soil.
What will they learn, do you think? What are they going to be able to find out?
They're going to learn the chemistry, John. The spectrometer will give us the chemistry of Mars.
Fellas, can I interrupt for a second?
John.
We just got word that a different sequence of photographs from the surface of Mars is about to be coming in to Jet Propulsion Lab Mission Control there in California. We're going to watch those pictures as they come in, I would reckon. And as we continue to look at the pictures that came down a couple of hours ago, until we get the new pictures, let's go back and look at the old ones. Some of our viewers have called and asked about the shape of some of the rocks. Now, not in this picture, those rocks look like rocks, but there are some that we have seen throughout the evening that look almost as if they might have been carved. I mean, they have very straight curves on the corners. And as we look at that, I'd like you, Story, because you've got a certain interest, a great interest in geology, to tell me how that could come about. If we can, I don't know if we can find one of those pictures while you're looking at it, but I've seen several tonight that look sort of like they've been cut pieces of stone. How would that occur naturally on Mars?
And I agree with you very much, John. They look fractured. They look almost as if something broke the rocks, and then after the breaking, there was minimum erosion to round off the corners.
I guess that tells you a little bit about the winds and the sandstorms and things on the surface of Mars. Probably hadn't been much windstorm or sandstorm action on those rocks to keep the sides of them as smooth as they are.
Or it's fairly recent.
Yeah, that's a good point. And we're going to learn, I guess, a good bit about the age of these river valleys as soon as we can get a sample of this stuff from the surface of Mars back to Earth, so that we can do some sort of dating on it. Maybe carbon dating would work on samples of Martian soil and the pieces that'll come back. I was asking Donna Shirley and a couple of other people earlier today how long ago this river basin had water in it. She said, don't have a clue, won't have a clue till we get some of this stuff back on Earth and can analyze it. There are some of these rocks that seem to have fairly square corners. This is just fascinating to look at to me, Story.
It sure is. It's amazing the diversity that you get in planets that all got formed in the solar system, depending upon where they got formed, what their orbital mechanics, how far out they are, what their rotations are, and what their chemistry was.
You know, Story, some of those look almost as what you'd see out in the West out here in the United States, where you have the great rivers that carved these canyons through there, and they really smooth them out over the eons of time.
Very familiar territory.
Story Musgrave, I'm told that the day you came to work for NASA, at the end of the Apollo days, it was your assumption you were going to be the first human being to walk on Mars. Is that true?
I thought we would have been there in 30 or 35 years, and with the acceleration in technology that we had, I think it was reasonable to expect that within 30 or 35 years we would be there, and I was a long-term investor.
Yeah.
And I was interested in life out there and in medicine.
Well, you know, your life's not over yet. How old are you today?
I'm going on 62 next month.
All right. Well, see, I mean, you got time, and you're a young 62. We got to take a quick break, Story. We'll be back with you and John Zarella, the rest of our crew. What a day this has been. To all our viewers who are sending us email and calling us up to ask questions of our guests, thank you all for being with us today. Big day for CNN. This is a live picture from inside NASA's Mission Control at the Jet Propulsion Laboratory, where new pictures from the surface of planet Mars, the second series of post-landing pictures for the Pathfinder probe, are beginning to be presented to the experts there. They're going to look very similar to the pictures we have seen over the past 4 hours, but the sun angle will be different because the sun is shifted in the sky. People all over the world are participating in our coverage tonight, watching these live pictures from Mars all over the place. At Planet Hollywood in Washington, the National Space Society put together a big wing-ding. Education Director Carolyn Josephs joins us now. Carolyn, I have a 4-year-old, and I know a lot of children who are in the 5 to 10-year-old age group who have seen these pictures tonight and really been knocked down by them. Is this going to help stimulate interest in space science, do you think?
I hope so.
Yep. What do you think the offshoot of this might be as the education director of the Space Society? I mean, there are people who've created CD-ROM programs to show people animations of these various things. Is this going to be a good thing?
I think it is. Our chapter does too.
Yeah. Okay, Carolyn. Thanks very much for joining us. Looks like a big party there at Planet Hollywood in Washington. All right, back to Pasadena. Story Musgrave, John Zarella. More pictures will begin coming down pretty soon. We're going to compile them here. If they look remarkably different from the pictures we have seen before, we will pop in and share them with our viewers. Just a remarkable night. Yeah.
We may, John, have some photos that'll give us an idea whether they were able to retract the airbags if they performed that maneuver, because there was some talk that they were uplinking the commands to the vehicle not long ago, so it's certainly possible.
Yeah, I think that's what I'm hearing in my ear, John, that these pictures will show whether they've been successful in getting this thing ready to get the rover off. But so much has to be just right for this to happen. The rover on Mars has to be able to see the Earth. The sun has to be up to charge the solar panels. So it's a very complicated thing. We've only got a couple minutes left in our live programming here. Story Musgrave, You got any final thoughts before we sign off here tonight about the meaning of this, sending unmanned robots to Mars and the prospect of having human beings, you or me or my 4-year-old Jay, walking around up there someday?
Well, John, when he landed on the moon, I was in mission control, and after the dust had settled, so to speak, I had to go outside and look up and take a look at the moon. The moon had new meaning, and what it was to be human had new meaning, and I have not looked into where Mars is tonight, but I will look into that, and hopefully it'll be visible tonight or tomorrow morning to go out there and take a look at that planet and realize that we are there and that the quest continues.
All right, it's on the west side. Look to the west, just above the horizon. It might have already set for the night, but you'll be able to see it just around sundown tomorrow. That's all over the United States, I'm told. John Zarella, you come back to me before in our final minutes here and give me your final thoughts on this. What a day. What a day of remarkable information and visual information.
And you know, it's one of those days where the hours just click by so quickly because one event after the other, starting very early this morning, was happening here with the descent through the atmosphere and this very 4.5 minutes of just one pyrotechnic event after the other having to take place perfectly for this to work, and everything did. John?
John Zarella, thank you very much. And to our hundreds of viewers, we have gotten more phone calls today from people watching this on television wanting to know more. Thank you for participating in our live coverage. For the whole CNN team, John Holland, good night. Thanks for being with us.
The first to be transmitted to Earth from the red planet in 21 years. The quality of the pictures, which are both black and white in color, has astonished everyone. NASA scientists are hoping to find further evidence to support last summer's detection of possible signs of life on the planet.
Wenige Stunden nach der Landung gestern Abend übermittelte sie eine Serie gestochen scharfer Farbfotos. US-Präsident Clinton sprach von einer neuen Ära in der Weltraumforschung. Die erste Erkundungsfahrt des Roboterfahrzeugs musste allerdings verschoben werden. Es soll ferngesteuert von der Erde aus die Umgebung des Landeplatzes untersuchen.
Die ersten Farbbilder vom roten Planeten waren von überraschender Qualität. In der Ferne kann man sogar Berge erkennen. Der Landeplatz heißt Aris Vallis, ein uraltes Marstal. Wie erwartet ist es mit Steinen und Felsen übersät. Die Kamera zeigt den kleinen Rover noch zusammengefaltet auf seiner Rampe. Die weißen Stoffteile sind die Reste der Airbags, die die Landung abgefedert hatten. Diese revolutionäre Methode hat die NASA zum ersten Mal bei dieser Mission angewendet. Anschließend gab es allerdings ein kleines Problem. Die erschlafften Airbags versperrten die Rampe. Hier sehen Sie, wie die Stoffreste über die Sonnenpaddel hinausragen. Wir mussten die Paddel nochmal hochklappen und die Stoffreste weiter einziehen. Auf diesem späteren Foto sieht es schon viel besser aus. Die schlaffen Airbags sind jetzt unter der Paddelkante. Trotzdem ist der kleine Rover erst frühestens morgen früh einsatzbereit, denn die Funkverbindung zwischen der Erde und dem Marsmobil ist gestört. Deshalb lässt sich das Gefährt noch nicht so fernsteuern wie in dieser Computersimulation. Die NASA will auf jeden Fall weitere kleine Rover zum Mars schicken. Die Wissenschaftler versprechen, aus den Fehlern dieser Mission zu lernen. Ihr Ziel, irgendwann einmal sollen die kleinen Fahrzeuge nicht nur Fotos, sondern Steine vom Mars auf die Erde schicken. Erst wenn die Wissenschaftler solche Steine unters Mikroskop bekommen, können sie vielleicht auch die brennendste Frage beantworten, ob es früher einmal Leben auf dem Mars gab.
About this topic, it's aerospace engineering, astronomy, and most importantly, the missions to Mars.
Kurt Grimold is an educator who wants everyone to be as excited as he is about NASA's missions to Mars.
And the best thing about it is, it's a lot of fun. You get to play with million-dollar toys.
Grimold is one of many teachers around the country who've been enlisted by NASA's Jet Propulsion Lab for their educational outreach program. It gives students an idea what it's like to be a scientist tackling questions like, why did the water that once was on Mars disappear?
Now, that's the kind of question scientists love to have. Something they can't explain, doesn't make any sense, but it makes a great career, trying to figure out why that happened.
Grimold used the talent and resources at hand at Georgia Tech to produce an interactive CD-ROM that could help answer questions about JPL, Mars, and the rest of the universe.
The CD-ROM was developed over a year ago for the purpose to get students, teachers more interested in space and be able to alert the K through 12 schools across the country of what is happening in the NASA and the Jet Propulsion laboratories in science.
Grimaud recruited a group of Georgia Tech aerospace engineering students to help create the CD. He added multimedia skills to their engineering know-how. For some, it changed their lives and their career goals.
When I came to Tech, I never, in my wildest dreams, thought that I'd be doing this for a living. And it happened so quickly. In the course of 1 quarter at Tech, when I took the elective class, totally changed my outlook.
NASA's hoping that students who use the Mars Navigator CD will be attracted by built-in challenges like maneuvering the Mars rover on the red planet's surface.
We have a delay on it, so it doesn't read to a new... Well, it crashed into a crater, so I guess I gotta go back.
The CD also surprises users with a rare look behind the scenes for advice from the experts.
When you go to school, don't worry about memorizing specific facts or equations. Worry about learning how to learn and being interested in a multitude of different subjects.
JPL scientists wanted the CD to explain the basics of space exploration and astronomy with lively animations and text.
And liftoff.
Once you understand those concepts, then your whole perception about your universe around you kind of changes a little bit. It becomes something more reachable.
In fact, one part of the program lets users reach out and touch the planets, arranging them in any order around the sun. If your solar system matches the real one, the CD is already in the hands of thousands of students and teachers across the country, and more copies are available from the Jet Propulsion Laboratory.
Das waren heute Nacht die ersten Bilder vom Mars, gesendet von der US-Sonde Pathfinder, der rote Planet in Schwarz-Weiß. Wer einen Computer mit Internetanschluss besitzt, konnte live dabei sein. Rund 100 Millionen Mal wurde dieses Angebot im Netz angeklickt. So viele Menschen haben sich noch nie an einem Tag für eine Seite im Internet interessiert. Willkommen im Heute-Journal. Als diese Schwarz-Weiß-Bilder auf den Computerbildschirmen im Kontrollzentrum der NASA auftauchten, brachen die Wissenschaftler in Begeisterungsstürme und manche in Freudentränen aus. Gesteinsbrocken und kleine Hügel sehen eben nur auf der Erde langweilig aus. Aber die Bilder zeigten auch ein Problem. Eines der Luftkissen, die die Sonde beim Aufprall abgefedert hatte, verhedderte sich genauer gesagt an einer der Landeklappen. Also konnte das kleine Roboterfahrzeug nicht ausrollen. Da weit und breit kein Marsmensch zu sehen war, hieß die Frage, wie zieht man aus 190 Millionen Kilometer Entfernung eine Airbag-Hülle weg? Elmar Thewesen berichtet.
Kleinere Probleme erledigt die NASA im Sandkasten auf der Erde. Hier kann man nämlich prima am Gerät ausprobieren, was zu tun ist. Dabei sah alles erst so unglaublich gut aus. Sojourner auf Pathfinder vor rosafarbenem Horizont. Solche Aufnahmen hatte die letzte Mars-Mission vor über 20 Jahren nicht zu bieten. Dass die Bilder da waren, löste zuerst mal Jubel aus. Und dann das unwiderstehliche Verlangen, mehr zu sehen, angesichts der Felslandschaft, in der vielleicht auch Geheimnisse des Lebens schlummern. Aber während alle in die Ferne schweiften, lag das Problem doch viel näher. Einer der schützenden Airbags hatte sich um die Räder des kleinen Rovers Sojourner gewickelt. Die NASA dachte scharf nach und kam auf den Gedanken, das Solarsegel mit Sojourner um 45 Grad anzuheben. Danach sollte das geschehen, was man im Sandkasten auf der Erde mal ausprobiert und was auf dem Mars nicht ganz funktioniert hatte. Ein kleiner Motor würde den Airbag einziehen. Tatsächlich hat die NASA jetzt den Weg für die erste Erkundungsfahrt freigeräumt. Es könnte losgehen, so wie im Acker auf der Erde, aber da hat die Fernsteuerung perfekt funktioniert. Denn manchmal kommt es anders. Die Kommunikation zwischen dem Pathfinder und seinem Huckepack-Auto ist gestört. Woran es liegt, wissen die NASA-Ingenieure noch nicht, aber die Steuersignale von der Erde kommen nicht an im Sojourner. Die NASA ist zuversichtlich, dass sie eine Lösung finden wird, aber so etwas lässt sich nicht im Sandkasten wieder richten. Ein Scheitern der Mission wäre möglich, nur bisher geht man davon aus, dass alles klappen wird, wenn auch verspätet. Dieser Mars-Mission sollen auf jeden Fall weitere folgen, 3 in den nächsten 7 Jahren, und die Bilder vom Mars sind die beste Werbung dafür. Das 21. Jahrhundert wird unseren Kindern Großes bringen, sagt er. Aufgepasst, Welt, hier kommt die NASA.
Watch out, world. Here comes NASA.
May the force be with you.
Letzte Nacht feierten die USA auch die Mars-Mission mit der Musik aus dem Film Krieg der Sterne. Ex-Astronaut John Glenn wird bald an einer Space-Shuttle-Mission teilnehmen und wer weiß, vielleicht schafft er es auch irgendwann bis zum Mars.
80 Meilen im Umkreis des Landeplatzes sollen in den kommenden Tagen erkundet werden. Besonderes Interesse richten die Raumforscher auf unterschiedlich gefärbte Steinbrocken, die sie für Zeugen verschiedener Entwicklungsstufen des Mars halten. Schon bald sollen die Kameras, deren elektronische Sensoren in Deutschland entwickelt wurden, ein 360-Grad-Panoramabild von der Marsoberfläche zur Erde senden.
Communication between the rover and the lander is degraded. We're hearing each other, but we're just kind of getting like, one syllable, across the net. We're not getting full sentences. We're really not able to communicate. So we're kind of in a degraded mode. The rover team worked very hard last night to look at various options. What can we do? There's a lot of things that we can do to fix these things. It's amazing what you can do from 120 million miles away. As of course the Galileo team demonstrated so incredibly with the unfortunate high gain deployment problem there. But obviously I'm confident, I think our team's very confident, we'll get to the bottom of this problem and we'll get the rover off hopefully sometime later today.
NASA hopes to determine some of Mars' geology as it searches for signs of ancient life on the planet.
Pathfinder ist auf dem Mars gelandet. Heute Morgen um 3 Uhr kamen die ersten Bilder vom Mars. 47 Schwarz-Weiß-Bilder, die auf der Erde mit einem Computer aufgearbeitet wurden. Und dann ergab sich diese farbige Ansicht des Mars, ein Wüstenbild. Nun, die berühmten grünen Männchen hat man auf dem Mars nicht getroffen, wie erwartet. Aber diese Aktion ist spannend genug. Guten Abend, meine Damen und Herren. Im Augenblick hat man keinen Kontakt mit der Sonde. Das liegt einmal daran, dass auf dem Mars jetzt Nacht ist und auch die Antenne dieser Sonde von der Erde abgewandt ist. In einer Stunde, so hofft man, hat man wieder diesen Kontakt. Nun gelandet ist diese Sonde so 20 Grad nördlicher Breite auf dem Mars und ironischerweise entspricht das gerade der Lage der Sahara auf unserer Erde, nur mit dem Unterschied, dass der Mars nur aus Wüste besteht. Nun, Probleme gab es schon vorher, vor der Landung, denn plötzlich enthüllte das Raumteleskop Hubble diese Sicht. Man sah ein riesiges gelbflächiges Gebiet, ein riesiger Sandsturm mit einer Ausdehnung von 1000 Kilometer. Und dieser Sandsturm, der bewegte sich auf den vorgesehenen Landeplatz hin. Jedoch, Gott sei Dank, wurde diese Aktion, die Landeaktion von diesem Sandsturm nicht gestört. Vorgesehen war ein Landegebiet in einem Gebiet, das so aussah wie ein altes, verlassenes Flusssystem. Das interessiert selbstverständlich die Wissenschaftler. Und interessant ist, dass man eine Landeregion vorgesehen hatte, so 100 mal 200 Kilometer. Und die Landesonde, die verfehlte den idealen Punkt nur um 20 Kilometer. Und die weiteren Fotos, die enthüllten etwas, was den Technikern nicht passte. Man sah, dass der Rover gar nicht herunterkommen konnte von dieser Sonde, weil die Luftballons, die also die Sonde schützten, das Ausrollen der Abfahrrampe blockierten. man versucht, dieses Problem zu lösen. In der nächsten Stunde hat man ja wieder Kontakt mit der Sonde. Pathfinder ist ja auch nur eine Sonde unter vielen, die jetzt auf dem Weg zum Mars sind oder in den nächsten Monaten, Jahren auf dem Mars landen sollen. Wir zeigen Ihnen mal den Weg von Pathfinder.
Der Weg durch unser Sonnensystem zeigt, welche Schwierigkeiten bei einer Reise zum Mars überwunden werden müssen. Die Erde benötigt 365 Tage für einen Umlauf um die Sonne, der Mars 687. Das Marsjahr ist also fast doppelt so lang. So ergibt es sich, dass alle 2 Jahre der Weg Erde-Mars besonders günstig und kurz ist. Beide Planeten stehen sich dann direkt gegenüber. Die Flugzeit einer Sonde beträgt jetzt nur rund 8 Monate. Und so wurde auch im Dezember 96 bei einer solch günstigen Position die Sonde Pathfinder gestartet. Bis gestern Abend unserer Zeit, kurz vor dem Abstieg, hat Pathfinder 500 Millionen Kilometer zurückgelegt. Der Weg von der Erde wurde durch Bodenstationen kontrolliert und der Kurs 4-mal korrigiert. Abstieg und Landung auf dem Mars laufen vollautomatisch ab. Die Anfangsgeschwindigkeit beim Eintritt in die Atmosphäre beträgt 27.000 Kilometer pro Stunde. Durch die Reibung in der Atmosphäre wird die Sonde abgebremst auf ca. 1.400 Kilometer pro Stunde. In dieser Phase gibt es keinen Funkkontakt. Das heiße Gasplasma um die Sonde schirmt Funkwellen weitgehend ab. Beschleunigungssensoren lösen bei der Bremsung die weiteren Schritte aus. Zwischen 11 und 5 Kilometer Höhe öffnet sich ein großer Fallschirm. Er bremst auf rund 240 Kilometer pro Stunde ab. Nach der Absprengung des Hitzeschilds wird um die Sonde ein Luftballonsystem aufgeblasen. Raketen bremsen die Sonde zusätzlich ab. Der Ballon mit der Sonde wird gekappt. Er fällt und hüpft über den Boden, ohne dass die Sonde im Innern Schaden nimmt. Das war um 3 Uhr früh Marszeit, also 19 Uhr gestern Abend. Die Gasfüllung wird abgelassen und die Landeeinheit öffnet sich wie eine Blume, vollautomatisch. Dies dauert rund 3 Stunden. Erst als mit Sonnenaufgang die Solarzellen zusätzlich zu den Batterien Strom lieferten und die Erde über dem Horizont sichtbar wurde, ging die Funkanlage in Betrieb. Der Mini-Rover sollte sich in Bewegung setzen und in den nächsten Tagen die Umgebung des Landeplatzes abfahren. Vor allem Gesteinsbrocken will man mit einem speziellen Spektrometer auf ihre Zusammensetzung untersuchen. Das ist besonders wichtig, fehlen doch weitgehend genaue Kenntnisse über die Zusammensetzung des Marsgesteins und des Bodens. Das Spektrometer richtet radioaktive Strahlung, Alpha-Teilchen einer bekannten Energie, auf das Gestein. Die dadurch ausgelöste Rückstrahlung gibt Hinweise auf dessen chemische Zusammensetzung. Ein weiterer Mosaikstein in der Erforschung unseres Nachbarplaneten.
Interessant für die Wissenschaftler ist ja der Vergleich mit der Erde. Gab es einmal Oberflächenwasser auf dem Mars? Wenn ja, warum ist es verschwunden? Viele Fragen bleiben offen. Wir zeigen Ihnen mal, warum der Mars für die Wissenschaftler so spannend ist.
Eine Reise von der Sonne durch unser Planetensystem. Der Mars ist der 4. der inneren Planeten. Heute zeigt er sich als eine eisig kalte Wüste, wie dieser Überflug, simuliert mit Hilfe von Fotos von den Viking-Sonden, zeigt. Man erkennt viele Einschlagskrater von Meteoriten und gewaltige Canyons. Einige dieser Bruchgräben sind über 4000 Kilometer lang. Dazu kommen endlose Hochflächen und Tiefebenen. Es gibt riesige erloschene Vulkankegel. Der höchste ist über 25 Kilometer hoch. In dieser Steinwüste toben Sandstürme, im Winter mit Geschwindigkeiten von über 250 Kilometer pro Stunde. Diese Sandwolken in der Polarregion kann man hier mit Hilfe des Weltraumteleskops als gelbliche Flächen erkennen. Vor über 3 Milliarden Jahren soll es auf dem Mars noch eine warme, dichte Atmosphäre gegeben haben. Wolken konnten entstehen und es kam zu Regenfällen, wie auf der Erde. Günstige Voraussetzungen für die Entstehung von Leben, meinen einige Forscher. Nach und nach soll die dichte, warme und feuchte Kohlendioxidatmosphäre zu der dünnen Schicht geworden sein, wie sie heute auf dem Mars zu finden ist. Ihre Dichte beträgt gerade 1% von der Erdatmosphäre. Die Durchschnittstemperaturen sind eisige -68 Grad Celsius. An den Polen haben sich riesige Mengen Kohlendioxideis und auch Wassereis gebildet. Man glaubt, dass sich auch in der Marskruste bis in große Tiefen ein unterirdisches Eisreservoir gehalten hat. So soll vor rund 16 Millionen Jahren ein Meteorit ein Stück Marsgestein ins All gesprengt haben. Vor 13.000 Jahren fiel dieser Marsbrocken auf die Erde. Spezielle Kohlenstoffverbindungen, eingeschlossen in diesem Meteorit vom Mars, und bestimmte mineralische Bestandteile gelten einigen Forschern als Indiz dafür, dass in der Frühzeit des Mars einfache Lebensformen auf diesem Planeten vorgekommen sein könnten.
Dieser angebliche Beweis über das Leben auf dem Mars ist unter Wissenschaftlern heftig umstritten. Denkbar ist es schon, dass es Mikroorganismen tief im Marsboden geben könnte. Man hat ja Untersuchungen auf der Erde gemacht und hat dort Mikroorganismen an Stellen gefunden, von denen wir uns nicht vorstellen können, dass dort Leben existieren kann. Aber man hat so den Eindruck, dass die NASA die Suche nach dem Leben auf dem Mars etwas überstrapaziert, es etwa als Werbegag benutzt. Die NASA-Missionen werden ja von Steuergeldern finanziert. Nun, die Landung von Pathfinder ist ja nicht die erste Landung einer Sonde auf dem Mars. Vor 20 Jahren gab es schon andere Sonden, zum Beispiel Viking 1, das hier ist die Landestelle von Pathfinder, und Viking 2. Und auch diese Sonden, die lieferten Bilder. Sie sehen, das sieht so aus wie eine Wüste. Mit der neuen Kamera von Pathfinder hofft man, dass man an dem Streulicht der Atmosphäre Rückschlüsse dann ziehen kann, welche Staubteilchen oder Wasserteilchen sich in dieser Atmosphäre befinden. Wir zeigen Ihnen jetzt einmal, wie die Missionen von Viking 1 und Viking 2 aussahen.
1976 bei der Viking-Mission wurden diese Landesonden ausgesetzt. Die Landung erfolgte vollautomatisch, denn ein Funksignal braucht bei dieser Mission von der Erde 20 Minuten. Also keine Möglichkeit, sekundenschnelle Abläufe direkt zu steuern. Die Temperaturen in den mittleren Breiten schwanken zwischen etwa +15 Grad Celsius zur Mittagszeit und -89 Grad Celsius in der Nacht. Eine Folge der dünnen Atmosphäre. Die Sonde sollte auch klären, ob Leben auf dem Mars existiert. Bodenproben wurden genommen und in das Analysegerät gebracht. Mit 3 verschiedenen Tests sollte organisches Material oder Spuren davon nachgewiesen werden. Die Experimente gaben keine eindeutige Antwort. Nur eines wurde klar: Wenn es überhaupt Leben geben sollte, dann nur in Form von Mikroorganismen und nur spärlich verteilt. Die Suche nach dem Leben war also damals schon unentschieden. 1989 schickte die Sowjetunion 2 Sonden in Richtung Mars auf den Weg. Sie sollten zunächst die beiden Marsmonde Daimon und Phobos erforschen. Die eine Sonde ging bald nach dem Start verloren. Die zweite erreichte Phobos. Hier sollte sie Aufnahmen machen und Messsonden absetzen. Danach war geplant, den Mars zu umrunden und zu fotografieren. Aber die Sonde lieferte gerade dieses eine Bild und ging dann auch verloren. Im November 1996 sollte erneut eine russische Marssonde gestartet werden. 14 Nationen waren beteiligt. Aber die 4. Raketenstufe funktionierte nicht richtig. Wie der Trickfilm zeigt, hätte die Mission den Mars vermessen und kartografieren sollen. Die 2 Spezialkameras kamen aus Deutschland. Außerdem sollte unter anderem das Magnetfeld erforscht und nach Wasser- und Eisvorkommen gesucht werden. Ein Vergleich zwischen den alten Viking-Bildern und den neuen, hochaufgelösten Bildern hätte interessante Ergebnisse gebracht.
Weltraum sind offen, aber diese Visionen sind selbstverständlich sehr fantasieanregend. Bemannte Raumfahrtmissionen zum Mars sind umstritten. 2 bis 3 Jahre benötigt man dazu. Und wenn man einmal Astronauten gesehen hat, die schon nach einem kurzen Aufenthalt im Space Shuttle oder in der Mir-Station auf die Erde zurückgekommen sind, dann sieht man, wie problematisch das ist. Durch die Schwerelosigkeit kommt es zum Calciumabbau in den Knochen. Das Immunsystem wird im Weltraum geschwächt und vor allen Dingen gibt es eine enorme Strahlenbelastung, Dinge also, die nicht unbedingt zu einer solchen Reise verführen. Und die Bilder, die man macht, die sind nicht nur für die Öffentlichkeit interessant und für die Öffentlichkeit bestimmt, sondern Wissenschaftler wollen aus diesen Messungen selbstverständlich Rückschlüsse auf die Zusammensetzung des Marsgesteins ziehen. Das reflektierte Licht wird durch verschiedene Filter betrachtet und daraus kann man Mineralogie aus der Entfernung betreiben. Aber die Bilder sind auch wichtig, wie wir gesehen haben, um Reparaturmaßnahmen durchzuführen. Die Bilder laufen zusammen in Pasadena in Kalifornien. Dort werden sie bearbeitet mit einem Computer. Es sind ja so 47 Einzelbilder schwarz-weiß. Die Antenne nimmt diese Bilder auf. Man kann vor diesen Bildern, vor diese Schwarz-Weiß-Aufnahmen verschiedene Filter schalten. Ein Computer, der errechnet dann die Farbe. Das sind Bilder aus einer alten Mission. Aber man hat ja die Bilder auch empfangen, jetzt von dieser Sonde Pathfinder. Man hat die Probleme erkannt, die durch die Ballonhüllen entstanden sind. Dann hat man noch Befehle gegeben, um die Ballonhülle hereinzuziehen durch Bewegung eines Paddels. Sie sehen, das ist die Ballonhülle vorher und jetzt danach. Und Sie sehen, das sieht schon viel besser aus, sodass man die Hoffnung hat, in einer Stunde, wenn man also wieder Befehle an die Sonde geben kann, wirklich diesen Rover herausfahren zu lassen. Das ist ja besonders wichtig, weil selbstverständlich die Energieversorgung für die Sonde hier blockiert wird in diesem Teil. Der Rover muss also herunter von dieser Solarzelle, damit alle Experimente dann ablaufen können. Der Rover, wenn alles nominal geht, der wird dann sich in einem Umkreis von 10 Metern bewegen. Der ist ja auch nicht besonders groß, so eine Länge von einem halben Meter und wenige Zentimeter hoch. Und dann wird das Gestein untersucht, es werden Temperaturen, sollen gemessen werden mit dem Equipment hier in der Sonde. Es werden Windgeschwindigkeiten gemessen. Die Aktion soll also dazu dienen, auch die Wetterbedingungen auf dem Mars zu untersuchen. Es kommen ja weitere Missionen im September. Da wird eine weitere Sonde in der Nähe des Marses sein, wird den Mars umkreisen und ihn fotografieren. Und ob der Mars der Zufluchtsort für uns Menschen sein wird, das ist äußerst fraglich. Vielleicht ist es doch besser, wenn wir zunächst erstmal unsere Probleme hier auf der Erde lösen.
It's the stuff of science fiction, but it's real. NASA tries to solve a problem on Mars. Hello and welcome to Early Prime. I'm Lyndon Souls in Atlanta. Gene Meserve has the day off. We begin 120 million miles from Earth on the planet Mars. There, NASA's Pathfinder spacecraft is sending back spectacular pictures of the planet's surface. But a communications glitch threatens to derail a main goal of the mission. CNN's Jim Hill reports.
Scientists and engineers are patting each other on the back over the latest pictures they've received from Mars. At the same time, they're scratching their heads over a problem with the 6-wheeled rover. It's only had partial communication with the lander, apparently because of a problem in the rover's computer modem.
The rover team worked very hard last night to look at various options. What can we do? There's a lot of things that we can do to fix these things. It's amazing what you can do from 120 million miles away.
Even if the problem cannot be solved, the rover can still creep off the lander and explore some of the Martian terrain on its own.
The rover has automatic software on board where once it is freed and the ramps are deployed, the rover will in fact drive down those ramps on its own without the help of the lander or without the help of our rover drivers here at JPL.
But engineers want to command or drive the rover themselves so they can analyze specific rocks and areas of Martian soil.
There's definitely two different types of soil here. That may be that some of the soil is brought in by a wind process and dropped onto this scene and therefore isn't really native to this area, or it may be for some other reason.
The clear, sharp pictures also show there seem to be different kinds of rock. In one area, they're slanted in the same northwesterly direction, perhaps confirming that a flood swept through the region. Also, hills can be seen on the Martian horizon, and the rim of a deep crater lies only a couple of miles away.
The most mysterious thing in this picture is this little object on the horizon that has been likened to a couch. Somebody suggested there was a homeless person camped out there.
The Pathfinder team is obviously in good spirits, confident, and excited about the information it's received. And of course, its mission is far from over. Jim Hill, CNN, at the Jet Propulsion Laboratory in Pasadena, California.
And for the very latest now on the Pathfinder mission, we go live to Pasadena and CNN's John Zarella. John, the mission controllers are saying that the communication situation is degraded and not lost entirely. What's the status of the situation right now?
Lyndon, just a few minutes ago, I was talking to one of the chief scientists here at the Jet Propulsion Laboratory, and he said to me, he said, you know, this is what exploration is all about. If you're not pushing the envelope, if you're not pushing the limits, if you don't have problems, then you're not really doing exploration. And that's what they're out there now doing, testing all new technologies that have never been used before. And what they are doing now is they've sent commands up to the spacecraft, to the lander, and they are waiting to get information back. And that should come in about an hour and a half. When they get that information, that downlink back, they will know whether the ramp has been deployed and whether the rover has stood up. The rover can't do anything unless they can get it to stand up. So that's a very critical thing that's going to happen in the next couple hours. They'll find out if indeed that happened. If not, they plan to send some more commands up and try and get the rover to execute those commands. If all that happens as we progress through the evening, later this evening, the rover will finally get off of the ramp. The rover will then take pictures of the lander. And then we will really get the geologists tantalized as they will finally be able to get some samplings of some rocks that they really want to get that rover over there to, so that it can start using that spectrometer it has and sniffing those rocks and doing chemical analysis. They're very confident here. They do believe they can work these glitches out. After all, they sent this spacecraft 120 million miles, as you pointed out, which was no small task, and managed to do some phenomenal work up to this point. Now, this has to be considered a successful mission, they say. Early on in the project, they were telling me that if they just landed on Mars safely, if they just got one picture back, this would be a successful mission. So already, Lyndon, they have far exceeded any of their goals, although obviously as scientists who are pushing the envelope, they want to get that rover off. It is the centerpiece of this mission, and we're going to be building up to some exciting moments throughout the day and evening today. Lyndon?
What else are they hoping for in terms of changing conditions that may help them with the reestablishment of that communications link, John?
Well, what we have now is that the sun has come up on Mars, so they're getting the heating of the day, and they are also then able to get the solar batteries charged up. The vehicle basically goes to sleep during the Martian night, and now it's awake. And also the Earth, which is a morning star in Mars, has risen a few hours ago, which will make it better and better for them to communicate with the vehicle on Mars. Hard to believe we're saying that, talking to Mars, but that's exactly what they're doing. And as with the Earth rise and the sun rise, it makes it much, much easier for them to send these commands and to get the signals. This is a Mars day, so this is the timetable that they are working on right now. Lyndon?
Well, we're going to be holding our breath along with all the folks at NASA. John, thanks very much.
Indeed.
CNN's John Zarella in Pasadena. NASA plans a news conference in a few hours to give us an update on the Pathfinder, and you can catch it right here. CNN's live coverage begins at 8 p.m. Eastern, 5 Pacific. We are standing by for a scheduled NASA briefing on the Mars mission. We'll bring that to you live as soon as it begins. Anxiety has given way to exhilaration for the scientists now that they've remedied a potentially crippling communication problem with the Mars Pathfinder and its robot rover. CNN's John Zarella has been following the story. He joins us now live from NASA's Jet Propulsion Laboratory in Pasadena, California. Hi, John.
Good evening, Lyndon. We understand that the briefing has already begun, so we're going to take you right inside and let you hear what the scientists have to say.
Minutes a day. Today, this afternoon, over at the Planet Fest at the Pasadena Civic Auditorium, I had the pleasure, extreme honor, of participating with Dan Golden and Carl's wife, Annie Druyan, naming the Mars Pathfinder lander the Sagan Memorial Station. Very fitting. Not only did Sagan inspire the general public, he spent a lot of time here at JPL. He was a participating scientist on many of the missions, and he inspired all of us rocket scientists here at JPL as well. Once I was on an agenda. There was this agenda, and it was all printed out. Tony Spears on the agenda making a presentation, and Carl Sagan was making a presentation. I was so excited about that, I almost forgot what I was going to say. Over the last couple days, we're verging on near miracles, okay? My wonderful team, led by Cookie here, Richard Cook, and I'm wondering if Carl Sagan is not looking down on us, smiling, having fun. Maybe he had a hand in a couple of these events that have happened over the last day and a half. That's all I have to say. I'm very proud that now Mars Pathfinder lander is the Sagan Memorial Station.
Okay, well, I think our excitement continues today. For those of you who've been listening in on the VoiceNet, you can tell that this morning has been an interesting, or this afternoon has been an interesting afternoon already. We've just completed a transmit downlink session on the spacecraft in which we got a number of interesting results, led by the fact that we're now receiving communications from the rover. Matt will discuss that in a minute here. But in addition, we have discovered that during the night last night, actually right at the end of the activities on Sol 1, so at about 10:30 last night here in Pasadena, the spacecraft flight computer reset. And what happens when a reset occurs is the spacecraft essentially terminates all of the sequences which it's running and goes into a kind of a, not really a safe mode, but essentially sort of just turns on some of the receiver and the flight computer and just basically sits there and waits for the Earth to come along and tell it what to do. Normally, we would not have known that activity took place because we would have expected the communications from the spacecraft in the morning and not received it. But as it turns out, in order to troubleshoot the rover problems, we scheduled a special downlink this morning, which was performed nominally, and so we got the data back which said that this reset had occurred. The spacecraft is fine. The lander's fine. It essentially operated all night just as it was supposed to, and we got the data back telling us that that all of the subsystems were performing fine. But we're a little perplexed as to what happened, and so we're right now, hopefully, we are transmitting commands to the spacecraft that tell it to start a new downlink session in which we're going to send some more diagnostic data down. And then we should be able to figure out what happened. But essentially, it did not adversely impact us really in any way, but we do want to understand what happened. But overall, because of the fact that we also this morning received additional images of the area behind where the rover is sitting, we feel like we're actually, once we get this next set of data down, that we're really able to then go on with the remainder of the day's activities, picking up essentially where we left off yesterday with the ramp deploy and eventual rover egress. So I think that's it. I'll let Matt talk about what they've learned from the rover side.
As I said a little earlier, we feel like somebody just invited us back to the party. We've got, as most of you are aware, we had an issue last night with the rover communications in the lander where we had a degradation of our communications link. The rover team got together and valiantly worked through the night. They came up with a number of possible scenarios, and they developed a list of potential fixes for those scenarios. And we implemented a number of those this morning, actually, just before the downlink. And when the downlink started, as you just heard Richard mention, we did, in fact, receive good rover-to-lander communications. And all the indications are that the rover was, in fact, doing exactly what it should have done, which was to perform its run-out sequence from yesterday and wait for new commands. It did receive a new sequence from us this morning, which essentially told it to continue to communicate with the lander and to wait for further instructions. And so that's where we're at with the rover. The team, I can tell you, is extremely pleased. There are a few touchdown dances done, I think, when we get that information. And we're ready to move forward here and get the rover stood up and egress down the ramp.
Okay, we'll go to Q&A momentarily. First, I just wanted to mention that we're going to be discussing with the project plans for our 9 p.m. press briefing tonight. It's possible that we may not really have significant new data to release then, so that briefing may be canceled. But please check with the newsroom to see what the status on that is. And the team's under a very tight deadline, so we'll try to move very quickly with our questions. Let's see, can we get one to John Wilford?
John Wilford, New York Times. If there's not a briefing at 9 o'clock, what happens if the rover goes out? Will we get some feed on that at that time? Or could you go over, has there been any change in the timing for stand-up, ramp, egress, and all those things?
The plan is still to, presuming that we get information back in this next downlink, which looks good, which tells us what happened, and I think we will, we should be able to move forward with ramp deployment in the next hour or so after that, hour to 2 hours. And then actual rover egress could occur 2 to 3 hours after that. So we're
3 hours after what?
After the ramp deploy.
Ramp would be what? Give me just round figures.
6:30, 7 o'clock.
What?
About 7 o'clock.
7 o'clock is ramp. And 3 hours later?
2 to 3 hours later after that would be the rover.
And just to answer your question about how we would communicate that to you, we will in any case have commentated mission coverage on the video monitors running until 12 midnight Pacific time. So you'll be able to check the status that way.
I don't need to add that, you know, I'm sure you guys have, you've already convinced you over the last day and a half that things are somewhat uncertain and that things will happen at the rate at which they're going to happen. So that's just my guess, but at this point, we'll have to see how things go.
Andrew?
Andy Chaikin, Popular Science. I just want to make sure I understand what you think happened to clear up the problem with the modem, the communications. There were two things that you mentioned. One was that the lander's computer reset itself, and was that what cleared it up? And the other thing you mentioned was that the rover received commands that you sent last night, and what role did that have in clearing it up?
Okay, let me clarify that a little bit. The telemetry that we got this morning, we're still looking at to understand exactly which of the potential fixes that we implemented actually was what allowed us to open up that communications channel with the lander. And so we're still really a little uncertain as to what in fact was what ultimately gave us the ability to communicate again with the lander successfully. But right now we're at about an 80% success rate. A couple of possibilities, one of which is that the modem or the hardware that the computer uses to interface with the modem, either on the lander side or on the rover side. These actually are identical on both sides of the interface. There's a possibility that a piece of that hardware hung, something like your computer would hang when you're working on it, and that the shutdown of the rover overnight, which is a normal thing for us to do, would have cleared that up. That's one possibility. We also switched the power supply on the lander side to the modem. We have essentially one modem on the lander, and we have two power supplies. So we switched the power supply to that modem. That may also have been what cleared up the communication degradation. And there are one or two other, perhaps less likely possibilities. But we're going to need to take some time to look at our data and at the lander's data to really know for sure.
Okay, William?
Yes, William Boyer for Space News. So is it at this point you really don't know what caused the problem, so you don't really know if it's going to happen again in the future? And then is this fail-safe mode for the rover, is the clock still running on that and it's potentially going to start doing its own thing? You talked last night about how it would go and just deploy itself automatically.
Yeah, that's right. Well, until we understand which fix it was that actually corrected the degradation in the communication link, we're not going to know for sure what the cause was. But clearly, if it was correctable once, we feel like there's very high probability we could correct it again. And relative to the contingency sequence, since we have now received a new sequence on board the rover, the one which we uplinked just before this lander downlink, that to some degree has reset that counter. However, it's always hovering there in the background. In the event that something happens down the line on the rover, it will actually implement and carry on with the rover mission.
Yeah, Paul Wilkerston, USA Today. Richard, in between sunrise and sunset, Earthrise and Earthset, and all these times, how many hours a day, Earth hours, does it work out that you're actually in two-way communication with the lander?
That we're getting, the times at which the spacecraft is transmitting data to us is relatively short every day, between 2 and 3 hours. We are usually transmitting to the spacecraft all the time between Earthrise and Earthset, or at least as much time as we have DSN station coverage, which sometimes isn't continuous. But for the first couple days, it's been continuous from Earthrise to Earthset. That's about 12 hours.
Key?
Key Davidson, San Francisco Examiner. This morning there was some discussion by Paul Smith about an interesting looking object quite a ways in the distance that some people have compared to a couch or an old seat cushion or whatever. Assuming that all goes well with the rover, is the rover capable of traveling whatever distance it is to that object and getting a better look at it?
Well, with the other issues that we've been dealing with actually over the last day or two, we haven't had a lot of time to view the scenery, so to speak.
Yeah.
We're going to start doing that sort of thing now, obviously, and looking at potential rover targets and operations areas. And, for the first couple days, we'll really just have a learner's permit relative to driving the rover. It'll take us a couple days to get our sea legs, and then we'll start to venture out a little farther away from the lander. How far we go really depends on how long the rover mission lasts, I think.
But isn't it true, we're talking about tens of meters, most likely, how far the rover gets away.
Okay, one back here.
I'd like to ask the three of you to maybe look back upon the most concerned moment you had in the last 12 hours. What were your fears when there wasn't this direct link with Sojourner? How nervous were you, and what was the mood at Mission Control?
I think the mood has always been optimistic. I mean, particularly after yesterday when we had so many things go right. I mean, it was like, we need to persevere here and things will take care of themselves. It's been, I've mentioned many times over the last few days that this is somewhat of a ride, a wild ride for the flight team. And I mean, there is a lot of stuff that's happening and it's pretty dynamic and actually it's really fun. I mean, this is really what we're here for. I suspect that when we get the rover off, that things will settle kind of down and be a little less dramatic, and in a sense we'll miss these first few days. We're all up there having fun. I don't think anybody is really down in the dumps or depressed or anything.
You know what I sense hanging around up there is no one thought anything broke, and everybody was confident that we're going to fix it. And so we weren't really that down. As a matter of fact, we were very up.
Irene?
What's the rover
mission began, was it in constant communication with the lander, or is it data taped and then relayed at specific intervals? And then, just one other question about the rover mission for tonight. Once it's off the ramp, exactly what do you propose to do with it tonight?
Okay, your first question. The rover typically will attempt to communicate with the lander during daylight hours on Mars about once a minute. So it's very frequent communications. It goes and looks for new instructions essentially about once a minute. At nighttime, however, to conserve power, we typically will command the rover to shut down and to hibernate, sleep, and wake up typically once an hour to do just sort of a check with the lander to tell the lander that we're still here and we're still okay. Relative to what we're going to do this afternoon and tonight, most likely if we get to the point where we have a successful ramp deployment and egress, we'll just drive down the ramp. We may do a small turn, but very little other than that. And then we'll drop our spectrometer, which is on the rear side of the rover, down onto the soil and start to take some overnight measurements of the soil.
Joe?
Joe Palca from National Public Radio. Have you made any plans yet of when you'll deploy the IMP mast?
Right now, the plan is to do it late this afternoon, Mars time, late this evening here. That'll be actually after rover deploy. It'll be around 11 o'clock tonight. So we won't actually get images back from the deployed position until tomorrow. At the earliest.
Todd Halverson of Florida Today. I think you guys were going to take the insurance panorama with the IMP today, and I was wondering when that panorama would be coming down, if it is in fact coming down.
Actually, the plan is to take those images right before we deploy the camera, and so it'll occur fairly late this evening. Those images, because they're, quote, insurance pans, aren't really high priority once we deploy the camera on its mast. And so what really will happen if we follow the normal plan that we have is tomorrow we would acquire some more interesting stereo imaging, which would in fact jump in front of that in the queue. The only reason why we may begin to get some of that is that in fact we're able to support much higher data rates than we were using in planning. Right now we're at about 4740 bits per second, which we probably can turn that up a little bit as well and go up to the next, at least probably the next higher data rate than that. So in fact, we may end up getting some of that insurance data back as soon as tomorrow. So.
Okay, the team's on a tight schedule. Let's just take a couple more questions back here, and then we'll get Kelly and wrap up.
Fred Villanueva with KTLA TV. You have better technology as far as camera lenses and so forth now, which gives you more accurate pictures and better color, more accurate colors and so forth. What will the improved pictures be able to tell you from 21 years ago, as far as lenses are concerned, what you're seeing?
That's probably a better question to ask Peter Smith, really. I'm not sure I'm the best person to answer it. I think that probably the biggest single advantage is the number of color filters, actually. It's not necessarily the resolution of the camera per se, but it's the fact that each one of the eyes, so to speak, has 12 filters on it, so we can get a lot more spectral information from the camera than let's say, the Viking camera would be. But I guess I would kind of defer that to have you talk to Peter about it. So.
But that's
All right, well, that has been a briefing here by the NASA engineering team of the Mars Pathfinder program. And basically what they're telling us is they're taking their time. They're not going to rush things. In the next couple of hours, we should know if we have ramp deploy. And then about 3 hours after that, we should know if they were able to get the rover off of the ramp. That will probably be the extent of the activities today, but things are certainly looking up. Donna Shirley.
Yes, they are.
They are looking very good. A very good chance then tonight. The rover's off the ramp. What are they doing right now? Why are they being so cautious?
Well, they're being cautious because we don't understand what happened last night. And so rather than rush into anything, they want to be sure that they understand the condition of the rover. They want to understand as much as they can why whatever happened last night happened. And they want to make sure that what they're going to do is the right thing to do. So they're diagnosing the data from last night, you know, sort of poring over it to try to understand what it means. They're also busily planning what to do next. And there's several options that they have. For instance, they know that the alpha proton X-ray spectrometer has already been released, that apparently some of the rover release has taken place because they've got data that shows that. And so, but the ramps are still rolled up. So now they're trying to decide, do they unroll the ramps first? Do they unroll just the front ramp or just the back ramp or both? Do they stand up before they unroll the ramps, or do they unroll the ramps first? So they're trying to make decisions like that that are going to maximize the chances of a successful rover deployment.
And you've got to get the rover to stand up before it goes anywhere, correct?
Right, absolutely. It has to stand up, and it's right down like this. And these are the rocker bogies, let's say, which are the levers that hold the wheels. And what happens when it stands up is there's a wheel here and a wheel here, and it drives those wheels together so that this flexes up and then click, latches into place. And that's what they want to make sure happens. So they want to make sure they understand the configuration of the rover exactly before they do that drive up.
Now, there's been a lot of talk that the rover might only last a week on the surface of Mars.
Right.
The mission was scheduled for a week. But this delay doesn't mean in 5 or 6 days now the rover's going to stop working.
No, the week was chosen for mission design purposes. We had to pick something. So we said, okay, let's try, just to make sure that we can get what we need to get done before anything could possibly happen to the rover. Let's say a week. What can we get done in a week? So that drove us to want to get the rover off very quickly. Now later we discovered that the lander wanted to get rid of the rover just as bad as the rover wanted to get off the lander, because the rover's sitting on their solar panels blocking some of the solar energy. So after a few days, if the rover doesn't get off, it may compromise the lander mission because it would be able to transmit less.
All right, Donna Shirley, thank you very much again for taking time in a very, very busy schedule to come here and join us. And Donna would also tell you that the rover has instructions to take off on its own if it doesn't get some commands after a predetermined amount of time. So they do want to get this taken care of and move on now and get the rover off so that the geologists can get out there and start getting all that great data from what they say is just a tremendous site that far outshines anything in the Viking lander sites from some 21 years ago. So from here at the Jet Propulsion Laboratory in Pasadena, California, this is John Zarella reporting live.
Big sigh of relief. John, thanks very much. Welcome back. Joining us now to give us some more insight into the Pathfinder mission is Lon Raines, the editor of the newspaper Space News. He joins us in Washington. Lon, thanks for being with us.
Oh, glad to be here.
You as jubilant as those mission controllers in Pasadena right now?
Oh, absolutely. It's been a great weekend. For everybody that loves the space program and has followed it, this has just been tremendous. And I think one of the things that's so important is to recognize what this mission cost. This was $250 million compared to $3 billion spent on the Viking missions in 1997 dollars. And that, I think, shows that better, faster, and cheaper works.
However, are we seeing some fallout for that in terms of the communication problem that existed? Because I understand it did show up in the ground testing, and that might lead some folks to wonder why there was no backup modem installed either on the base or the rover itself.
Well, the reason is that to save costs, you have to take some greater risks. And one of the things that happened here is that they decided they'd only go with one modem on both the lander and on the rover.
But you would think after spending this amount of money to get the spacecraft there, that they would at least have the very basics on board in case, again, this problem that reared its head in the testing occurred in the actual mission.
Well, again, the idea is to save money and to mount a lot of missions. We're now doing 2 missions to Mars every 26 months compared to 1 every 10 years before. And so if you make a mistake, you have a chance to make it up, whereas before you did not.
Now, we've got the drama concerning the Mars mission. We've also got the various and still serious situation on the Mir space station. Are these 2 missions, do you think, helping to regenerate public interest in space itself and support for additional funding for these kind of missions?
I think they are. I think one of the things that we've noticed over the last year or so is that this has been front page news on newspapers in the United States, whether it's USA Today or the Washington Post or New York Times. CNN devoted almost an entire day yesterday to the Mars mission. I think it is generating more public interest, and whether it generates more money or not, I think is going to depend on Washington politics and the budget deficit.
Well, that's a whole other story that we don't have time to go into, but Lon Raines for now, the editor of Space News, thanks very much for sitting in with us. We appreciate it.
Glad to be here.
And that's all for this edition of Prime News. I'm Lyndon Souls at CNN World Headquarters in Atlanta. For our international audience, Inside Asia is next. And for our viewers in North America, please stay tuned for CNN Sports Illustrated.
Welcome back. I'm Leon Hawthorne. Style with Elsa Clench is just ahead. But first, this check of our headlines. Updating the Mars Pathfinder mission, Mission Control has confirmed that the remote control rover called Sojourner has been deployed towards the surface of Mars. It's expected to take some 5 minutes for the slow-moving rover to move down the ramp, and a camera on the Pathfinder landing craft is positioned to get images of the rover's movements on the terrain. Pathfinder has sent back images showing both the front and back ramps extended from the lander to the Martian terrain for the rover to use.
Pathfinder übrigens wurde inzwischen umbenannt in Carl Sagan Gedächtnisstation zur Erinnerung an diesen einzigartigen Mann der Wissenschaft, der dazu beitrug, dass die Menschheit das Träumen von der Zukunft nicht verlernt. Einziges Problem der Expedition waren die Startschwierigkeiten des Mobils. Ein zur Landung ausgebreitetes Luftkissen verfing sich mit einem Teil des besagten Mobils, doch auch dieses Problem haben die Experten inzwischen in den Griff bekommen.
Jubel bei den Wissenschaftlern im NASA-Raumfahrtzentrum Pasadena. Ihnen ist es gelungen, die Kommunikation zwischen Mars-Sonde und dem Robotermobil wiederherzustellen. Damit steht einer Inspektion der unmittelbaren Umgebung des Landeortes nichts mehr im Weg. Zwar ließe sich der Roboter notfalls auch per Mausklick von der Erde aus steuern, NASA-Manager Muirhead räumte jedoch ein, dass die Bedienung des Gefährts nur vom Computer der Sonde aus effektiv ist. Die ersten übermittelten Bilder belegen, dass der Landeplatz gut gewählt wurde. In unmittelbarer Nähe zu diesem Krater, gefährlich nah sogar, meint der Wissenschaftler, aber inmitten einer hochinteressanten Umgebung. Rund 20 Meilen im Umkreis des Landeplatzes sollen in den kommenden Tagen erkundet werden. Besonderes Interesse richten die Raumforscher auf unterschiedlich gefärbte Steinbrocken, die sie für Zeugen verschiedener Entwicklungsstufen des Mars halten. Schon bald sollen die Kameras, deren elektronische Sensoren in Deutschland entwickelt wurden, ein 360-Grad-Panoramabild von der Marsoberfläche zur Erde senden.
Hello everyone, I'm Catherine Calloway in Atlanta. An exciting night for NASA. We are expecting the first images of the Pathfinder on the surface of Mars. Let's go right to John Zarella, who is in Pasadena with the very latest on this. John?
Well, good evening. Indeed, NASA engineers are receiving a downlink right now from the lander, from the spacecraft on Mars, and during the course of this downlink, perhaps any minute now, you can see there inside Mission Control, they should be getting some pictures that will show them the Sojourner rover on the ground on Mars. It does not appear, now Donna Shirley, join in here when you can.
Okay.
It doesn't appear as if they have those images yet,
No, we don't
does
have
it?
them yet, but they should be. They have to. What the images do is they come down to the Earth, and they're caught in a big, giant antenna. I don't know which one. It's either Goldstone, Madrid, Spain, or Canberra, Australia, and then they have to be shipped via satellite back here. So there's a little delay.
The Jet Propulsion Laboratory in Pasadena, California.
Flight, go ahead, Rover.
We are receiving data. Support area.
We are receiving data. Okay, so the rover data is coming back.
Seated is Flight Director Chris Salvo.
They're laughing. It must be good news.
In the
No,
colored
no,
shirt
they'd be
is
cheering.
Project Scientist Matt Golombek. In front of him is Brian Muirhead.
That's Matthew Golombek on the left.
Right, and Brian Muirhead, the tall guy in the shirt.
We are
with the
going
blue
to
shirt.
let this view
And
go
Gordon
out
Wood is the animated one on the
just,
right with the
watch
white
and listen
shirt on.
in this high gain session that we
Gordon Wood
fully
is
anticipate
the
will show
telecommunications engineer
on the
who
surface
told
of
us
Mars.
that we weren't
This is
going to
Mars
hear
Pathfinder
anything
Mission Control.
after we entered.
And then you heard it all
And
the
then
way
we
down.
heard it all the way down.
I know they were
So,
saying they're going to let us listen real time as this entire, if I caught the drift of what he was saying, as this entire event here is unfolding, this downlink of data and images from the Pathfinder vehicle. Now, the first images you will get will be taken from the lander of the vehicle on the surface of Mars,
That's
correct?
correct.
Of Sojourner.
That's correct. And I'm not sure whether we will actually see any images taken by the rover's cameras or not. they may decide to take it because they may put the alpha proton X-ray spectrometer right down on the ground without sending any more commands, and then they like to take a picture of that to see where it is. And the rover's rear camera, there's a little color camera on the rear that's got a very wide angle lens, and so it can actually see the ground and back of the rover. And
go ahead, APS. Did you guys put in the sequence?
No, they're just
There's pictures now.
Okay, there's a picture. All right. Let's see. Well, there. Oh, that's the sun.
That's the sun.
Yeah.
In the upper left-hand corner.
Right. Peter Smith. So a lot of these pictures. Now you can see on this chart. You see this little circle on the bottom here?
Right, the circle in the bottom middle for the viewers.
And then there's a kind of a ray going out from it.
See the ray moving.
And that's the direction that the camera is pointing. And now, these, I found out what these are. Yesterday I didn't know. Those are the magnetic targets. And those are the ones that are going to be attracting dirt, the magnetized dust, and they will stick to those targets. And these targets are different levels of magnification, so that if they have more dust on them, they're a stronger magnet. On Viking, they had some strong magnets, and the dust immediately went zoop and completely covered them. So there's a gradation of these magnets from strong to weak.
Any image here could pop up a picture.
That's right. You can't
We just don't know, but any picture now, we could see Sojourner on the surface of the planet.
Right.
And
because they don't just march around nicely around the circle. They come in at random somehow.
That will be historic.
Yes.
Once again, another historic event.
Yes, I'm watching.
The first autonomous vehicle.
These pictures don't come in all at once either. I mean, you get a bunch, and then they kind of wait and send in some more data, and then you get another bunch.
There's a tighter shot of that.
And that one's shinier too.
Yes.
I don't know if I can see I can't with my eye see any particular.
Now, for the viewers out there, if they're looking down at that center disc with the 3 pedals in it, the Sojourner rover is actually on the pedal that would be facing 3 o'clock. Is that correct?
However, it will now have backed off, and so it will actually be more like at 4 o'clock.
At 4 o'clock.
All right, that rover UART error handler message is nominal at this time. It's expected.
Continuing to show these same photos. So again, as we are going through this sequence, no order in which they're coming in.
Well, I don't know the order. There's some rational thought behind this. I just don't know it. See, now there's that one looks like it's a little farther away. But they got rover data, which means that the rover is talking to the lander. So the rover's communicating. That means the rover's communication system is in good order. And there were some problems with that earlier. If you recall yesterday, there were having some problems with that. So it seems to be in good shape today.
So the rover should be on the surface of Mars right now.
Right now.
And this is just confirmation of an event that's already taken place.
That's right. Now these images are from a little different angle according to the circle, but they look the same.
When we were talking earlier to Brian Cooper, rover driver, and Brian was saying that one of the interesting things, and you had mentioned it to me earlier as well, is that the landing ramp on the front is suspended in midair. It's actually floating because the Martian atmosphere is so thin. It didn't fall all the way.
Gravity.
I mean the gravity. It did not fall all the way.
That's right, because we designed these things to be stiff enough to support the rover when it's running down the ramps. And in this case, it was just stiff enough that it didn't actually fall down. Now, the rover only weighs 9 pounds on Mars. On Earth, it weighs around 22 or 23 pounds.
Here's a look at the animation of what should have taken place.
Right. Except that in this animation, the rover is going down frontwards.
Right.
The real one is going down backwards.
Is going down backwards.
Now, you want to know why it's going down backwards,
yes,
I bet.
Indeed.
The reason it's going down backwards, there's 3 reasons. One is that front ramp is up in the air. And the rover's weight would easily push the ramp down, no problem. But when the ramp dropped, the rover's software would say, whoop, something's wrong here, and it would stop. And so we don't want the rover to stop at the top of the ramp.
We're getting a whole slew of rover image engineering packet.
Rover image engineering. That means there's
from a previous sequence.
That means that there is actually, the rover is sending the pictures that its cameras took, which are different than the pictures that the lander camera took.
These are rover images then?
No, not these.
Not these.
Not these. See, we're still getting
getting
lander images. Rover images would be of dirt, I imagine, and you'd see a wheel in them probably.
Let me ask you then, when we are now looking at a continuation of these frames coming down, of an event that's already happened on the surface of Mars.
Right.
As far as we know, then the vehicle Sojourner is there.
Yes,
it's sitting
it's already there. But this is a confirmation of that. We don't want to take it on faith.
One of the concerns that was expressed also, even about going off the backside, was that there was still a little bit of that air of the airbag encroaching on the side of the ramp.
Right. And I believe they ran some tests. Well, they did run some tests last week to make sure that even if the ramps didn't deploy at all, or if there were big rocks stuck up against the pedals, that the rover could actually turn and go over the solar panels and clamber over the airbags and get onto the surface. And they tested that, and it was able to do it. Not something we want to do, but for one thing, it scratches the solar panels on the lander, which the lander doesn't like a lot.
Earlier this evening, I noticed that they were testing in the sandbox the procedure for the rover to be going down this ramp before they sent the command for it to do so.
Right.
Can you tell
That's
me
what we have the sandbox for, is to practice these things. And so in this case, there was just a little bit of airbag lopped over onto the ramp. And the engineers were fairly confident that there wouldn't be any problem, because the airbags we have here in the test bed are really old and beat up and stretched and scratched and threadbare. And if the cleats on the wheels are going to catch, they're going to catch in that old airbag material. The airbags on Mars are nice and new and fresh and stiff, and so we expected that the rover would just roll right over it without any problem. Well, we just seem to be getting a lot of these magnetic images here. So let me tell you about why it's going backwards.
Yes.
I said one time the ramp in the front is up, so we don't want to do that. Number two, the airbags are bunched up in such a way that if the ramp in the front were on the ground, we wouldn't be able to see very well. Oh, there's the back ramp. Okay. No rover. Whoop. Ah, drat. That was the back ramp. So the rover, if it's off the ramp, is farther out.
Further out
than that.
That would be the ramp the rover should have gone down.
The ramp the rover should have gone down. So the rover is probably off.
We're receiving imaging of the rover at the bottom of the ramp.
They say rover at the bottom of the ramp.
Well, boy, I don't see a rover in that picture.
There's no rover yet. There is no rover in those images yet.
There is no rover in those images
Do you see any rover tire tracks or anything?
No, I can't tell. In this view.
This is the same image again and again, it appears.
They're just taking it in different filters because they want to be able to tell the different colors. And so what's going on is he's taking this in just all kinds of different filters. And there's 12 different filters, remember. There's probably 20 or 30 images in each one of these things. And we don't know when. We know the rover isn't stuck on the ramp. Now, that we do know from this picture.
It's not on the ramp, but do we know that it's actually gone off the ramp? I mean, it could still be sitting on the pedal then.
It could. That's right. We don't know yet. Although they'll be able to tell from the rover telemetry how many times the wheels have turned.
Would they already have that information from the earlier
but
packet?
They're processing it. There it is. It's on the ramp. It's on the ramp. It's sitting on the ramp. Okay, it hasn't gotten all the way off yet. All right, they'll just send another command to tell it to go on down.
So right now it is sitting on the ramp.
Almost at the end of the ramp. And so what happened there, I mean, I'll speculate.
Here it's moving further off, though.
It's moving. Oh, okay, this is the movie. This is the movie.
The movie.
Yeah, this is a movie.
This is spectacular.
Okay, watch this. Here it goes.
2679 is complete, halfway down the ramp.
All right, there it goes. Okay, this is the same picture, just in a different filter.
Flight, we can confirm that our first move halfway down the ramp was successful with no errors.
Okay, so it's they have confirmation, besides the picture, that it was halfway down the ramp. Now, it still has to get all the way off. And so what they're going to do, I forgot that they did this during testing. They actually made a movie, click, 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 and they can run it as a movie, showing the rover getting down the ramp. So hang in there with us. We're going to get some more.
Some more images, a little further off, the first wheels off, and then finally the entire rover off.
But if it's this far, I'm real comfortable.
Moving.
Yeah,
I mean,
it's moving, it's functioning. Sojourner lives. And the back ramp is also good to go off because we can see the end of it, so we know that the terrain is safe to get off. And also there's this nice big knobbly rock right close to there. So what they want to do is they won't have to go very far to get the alpha proton X-ray spectrometer on the rock.
Was there ever any doubt in your mind? I know everyone here was so confident all day even despite the fact that they had the communications glitch. But everyone we talked with, yourself included, was, we'll figure this out. This is not a showstopper.
Right, right. No, I was telling some of the people that I was on the Mariner 10 mission to Venus and Mercury, and everything that could possibly go wrong with that mission went wrong, and we still went by Mercury 3 times. I mean, everything went wrong, and it took just this incredible ingenuity and hard work of the team to make it go. So that's JPL's specialty. Oh, that's the ASI mast. That's the weather mast.
The weather mast with the windsock?
Just over the little blip on the left, about halfway up, is the windsock.
Is the windsock.
Yeah, so we know the mast is deployed and everything's looking really good. I still want to see that last image of the rover on the ground. But even if we don't get it, I'm sure that the rover's on the ground because it wouldn't have stopped.
The folks standing there in mission control are really seeing this at the same time we're seeing it.
We're seeing you on
The
CNN,
world is
and your
seeing
viewers and the whole world are seeing exactly what mission control is seeing in real time. Modern television.
This has certainly turned out to be 2 incredibly exciting days that continue to far exceed.
Oh, there's an even better picture of the mast.
Of the mast, again, that's the meteorological experiment. You can't make out the windsock there, though, can you?
Well,
do you
it's
see
just
it?
a little off the picture to the left. See, you can just see a little white part there, which is the cone. And what's this saying is it's not blowing very hard on Mars.
You can
it's
tell
just hanging
to
there.
the viewers if they were to look to the very extreme left of the picture.
Right.
There
There's
are
a
these
little white bar
little white
out,
bar on the top,
and then there's just a tiny little
tighter shot of it now. There's a tiny little ball hanging down, it looks like, and that's the windsock, and it's not moving.
It's not moving. And it's not going sideways either. And so what one thing you could conclude from that is that this dust storm that's going on in Valles Marineris is not putting very much wind up at our landing site. So that looks pretty good.
It's been a calm day on the surface of Mars.
I should also tell you that the rover May experiment is working. Did Brian talk about that?
No, we did not.
Okay, there's a little experiment on top of the rover solar panel that actually measures the amount of dust that falls on the solar panel. And that experiment is working, and they have measured the amount of dust in the air and compared it with what they're getting from the pictures. And they think that there is some dust leaking over from this dust storm, but not a whole lot.
Oh, so they are experiencing a little bit of dust though, from the dust storm.
But that experiment is working, which is the nice thing about that.
Are they getting temperature readings yet?
Oh, yes.
From what have they been getting as far
I
as
don't know.
temperatures
Tim
from Mars?
Schofield will be reporting tomorrow morning. There'll be, I think, the 10 o'clock press briefing tomorrow is a science-oriented press briefing.
But they are now getting readings as to what the temperature is and the wind speeds are and the pressure, barometric pressures.
Weather reports from Mars.
We can start reporting those now on CNN, the weather reports on Mars. Well, they can. The images from the lander are continuing now to show that weather instrument there.
And again, they're going through it with different filters and slightly different positions of the camera. So that's what's going on.
And there would be about 15 or so minutes left, or 20 minutes left, in what was supposed to be about a 40-minute downlink, I believe.
Minutes? Okay.
This is what they had said.
Let's see what he says.
Yep. The camera deploy time is UTC 091420.
Oh, maybe they're going to try to deploy the camera tonight. Okay, now there's an image. Okay, that's just of the view. See, that's to the right.
This is Mars Pathfinder Mission Control at the Jet Propulsion Laboratory in Pasadena, California. There's a high gain antenna downlink session underway right now that includes, as we see on NASA TV right now, a view of the landscape. Previously, we were looking at the meteorological mast and 2 of the windsocks that were located at the extreme left-hand side of the screen, both of them pointing straight up, indicating
Telecom flight. Telecom. Can you tell me how our uplink and downlink powers look?
We can see, Donna, in that picture there.
Is -121.2.
Nice big fat rocks that might be a wonderful target.
It looks again in that one a little hilly area to the background.
Right,
and,
right. Little spiky things in the background.
Now is the camera, the imager, is still stowed? It has not popped up yet.
It has not popped up yet.
So for the viewers who don't understand what we're talking about, that means that it can pop up and get into several more feet higher, correct?
Right.
And start taking higher
right
images.
now is taking images from Mars with its chin
images were taken. This is over different
right
times.
on the lander's body. But the lander itself is sitting up above the terrain a little bit.
Like dice, dark spots on a white background. Those were
the
magnetic targets.
Right.
There's
the calibration target.
Dr. Matt Gollenbeck said that we'd expect to see, but we also saw the end of the ramp very early in this downlink. There was no rover there, and there was no tracks on the surface. That was perhaps a wee bit alarming until the realization of the fact that the rover was just not there yet. The next image showed the rover partially down the ramp into the field of view, and the image after that showed the rover almost completely down the ramp. And of course, the mission support area, as did other areas of the Jet Propulsion Laboratory, erupted when the rover was seen there. We are still waiting. We're probably several minutes away from the rest of the rover deploy images. Literally the world and the scientists are all seeing this at the same time. There's no delay between the NASA television feed and the feed that's being supplied to the mission support area and the science area here at the Jet Propulsion Laboratory. The entire world is watching these images all at the same time.
So while they're doing this,
we'll stand by and go clean with the feed for the rest of this downlink session. This is Mars Pathfinder Mission Control.
Okay, so there was a suggestion we talk about the cameras?
Yes.
Okay, the rover has 3 cameras. The 2 in front are black and white cameras. The one in back is actually a color camera. It's not a very good color camera, but it's still a color camera. And these are little Kodak CCDs, commercial Kodak charge couple device cameras, just like your little digital camera that you get these days. And their ones in front are actually mostly used for hazard avoidance. And as the rover starts to move in response to the direction that Brian Cooper gives the rover from Earth, she lays these light stripes out onto the ground from lasers, and those cameras see the light stripes. Now, but the cameras are, of course, also good for taking pictures. And so, for instance, a while back, we got a rover picture that showed the ramp still rolled up, not yet deployed. And that picture was taken by the rover's front cameras. Now, there's also a camera on the back that's this little color camera with a very wide angle, and that camera is used, number 1, to take pictures of the rocks that the spectrometer is placed on, number 2, to take pictures of the rover's wheel tracks so that we can see what's happening with the soil and how dense the soil is, and then 3,
of the rover egressing on the ramp in the next few minutes.
Okay, pictures of the rover egressing on the ramp egressing from the ramp in the next few minutes.
You can, just by looking at the tire or the marks of the wheels, you can study the soil. Geologists can study the soil.
Right. For instance, on Viking, when it dug the arm on Viking, which was the last time we landed on Mars, dug into the soil and expected it to be, really fluffy, but it wasn't. It was almost like it was wet beach sand, which is very strange because it's not wet. There was no water in there at all. And then they could see different types of terrain, which they call cloddy terrain and dusty terrain and things like that. And so the nice thing about the rover, we'll be able to roam through these different types of terrain and actually see what they're like. The rover's wheels were widened from the original design to get much wider because we tested it in a sandbox with lunar soil, or soil that was like lunar. Okay, and so that's what the cameras do, is take pictures of wheel tracks.
All right, well, we can see that they are continuing now on waiting here for these images of Sojourner on Mars. And
okay,
there
there's
again
another
is
picture
another
of the
picture.
scene.
Some local cable operators will be cutting away now for a commercial message, but CNN's live coverage will continue of Journey to the Red Planet.
Got more images of red.
Again, we see the same image once
Right.
again of that of the landscape, and as you were saying, it's taken in different filters, correct?
Right. Different colors. So,
well, we've lost our picture
right,
here of
I hope some viewers are still
there it
seeing-
is,
there
it's
it goes.
back.
Okay, it's back. The different colors go all the way from the red end of what you can see to the blue end of what you can see. So this actually has just as wide a range as the human eye. There we go.
There it is.
All right. On the ground. Sojourner is on Mars. Woo!
Look at the cheers.
Yeah.
You can hear cheering all over the Jet Propulsion Laboratory here this evening. Go ahead, Rover. This is
that a beautiful sight? Wow.
that is as historic a picture as we may see in our lifetime.
Go ahead, Rover. We can report visually 6 wheels on soil.
All right.
Right. See that?
6 wheels on soil. There's another one just taking a little. Oh, you can even see a piece of the airbag. See the tracks?
There's the track.
There's the tracks.
In the bottom left-hand corner of the picture for our viewers, you can actually see a rover track on the surface of Mars.
The very first Sojourner track. Now, it'll be interesting. I don't know if we're going to get another picture where we'll be able to see the back and see if she's put the spectrometer on the soil or not, but that's what we'll be doing for the evening. And that way, tomorrow morning, we'll know something about what Mars is made out of. Okay, there it is. There's the end of the ramp. She's well off the ramp.
Well off the ramp.
See you later. So everybody's celebrating like mad in the control room.
If you're just rejoining CNN, you're watching live
Mars
coverage
Pathfinder
of
Mission
Journey
Control
to
at
the
the Jet
Red
Propulsion
Planet.
Laboratory in Pasadena, California. At 10:59.5, the first images came up
For
on the
those
screens
of
here.
the viewers that just got back, just as we cut away, Sojourner is off.
Sojourner is on the surface of Mars, and in
Rover
this
team
image,
reported that they could confirm that there were 6 wheels on soil,
6 wheels on
meaning that
soil.
the rover is successfully on the surface, as can be seen in these pictures
You
here.
can't see the wheel track in this one very
absolutely
well.
ecstatic.
And is on the Mars surface.
But there is Sojourner on the surface of Mars.
speed, rest to fall ashore.
I believe I just heard NASA talking to Houston to pass on to the astronauts that the Mars Sojourner, it's on Mars.
It's on
Sojourner
Mars.
is on
It's on
Mars.
Mars.
This
And this is sort of like one small step for mankind, because if we can put robots on Mars reliably, eventually we'll be able to put
And now
people
the
on Mars.
successful
So the
deployment of the
astronauts ought to be
Sojourner
real
onto the
interested in
surface of
that.
Mars.
This is really the culmination for you of years and years of
and
hard work.
Right.
And
And
the
the
fighting the
life is
political
complete.
budget process as well, and going through a whole new build it cheaper, build it better, build it smaller, build it faster. And you came through it all, and with the team you've
There are a few more
assembled,
of these images that
this
are
is the
due.
culmination of a dream, isn't it?
That's right. It's absolutely a culmination of the dream. And the real beauty of it is that we put
And
this
then
team
this team will
together
report its findings
5 years ago. And then sort of the mother and father of the team were Bill Lehman, who was the chief engineer, who's the world's greatest engineer, and me. And both of us have left. And the team, Jake Matijevich and his team, have carried on without a flaw and just pulled it off. I mean, this is a complete team effort of a really brilliant, hard-working bunch of guys. And as is the whole Pathfinder project. I mean, it's not just the rover, but the entire Pathfinder project is just an experiment in how to do everything differently.
What goes through your mind from a very personal sense when you see these images?
Well, this is what I've been waiting 30 years for. No, 30 years ago, or when I came to JPL, I wanted to work on a mission to land on Mars. Oh, beautiful. Beautiful. There you can see the wheel tracks.
Are these the three-dimensional?
This may be. I don't know what this is. This is probably Brian Cooper's.
Brian
I don't know,
Cooper's,
that's not
no?
Brian Cooper, but
On the right side of
on the
that
right
picture
side, I
a
think
second
it's
ago, I
probably
thought was
Brian
Brian Cooper. And
first pictures of rover on Mars. I don't know where. Who's
home occasionally.
Rover, don't forget to call home occasionally.
See, these are much brighter now.
Yes,
I think this may be the Ames Research Center experiment. Now, we can't see the antenna. The antenna should be up.
That would be in the right where the basically where the pointer was going, wasn't it?
Right. Okay, I believe this is there's a little bright spot on the front of the solar panel, and that's the materials adherence experiment. And
there's the celebration.
There's the celebration. They're in a striped shirt. In the middle is Howard Eisen, who's the head of the mechanical team for the rover, and Sam Nguyen, who is one of the programmers of the rover. Brian Wilcox in the check shirt, who is the guy who developed the eyes.
Howard Eisen high-fiving there.
Yeah.
Howard had come out here earlier to talk with us, and I remember having Howard back 6 months ago, back on December 2nd, 2 days before the actual launch, doing a rover demonstration for us at the Kennedy Space at Cape Canaveral.
That's right.
And,
he and I were there on
you
the same
were there
day.
the same night, a cold night in Florida.
That was right.
In
Freezing
December.
to death.
Freezing to death. Not as cold as they are as the vehicle is on Mars, of course. It's a lot colder there. But just a fabulous team.
Here walking toward us is Art Thompson, who is one of the system engineers and one of the controllers for the rover. So practically the whole team is there.
It really enhanced those pictures tremendously.
This is what happens when you get them into these modern computer workstations.
It looks like there's a rock just to the left of Sojourner, doesn't
it?
She
ran right out. In fact, look, see, there's wheel tracks. I think she ran
right over a small one, and then up in the upper left-hand corner where the shadowing is a larger rock.
We ought to be able to tomorrow just turn right around and get to nail that rock.
Turn Sojourner right there. But tonight, Sojourner will sit right where she is.
And go to sleep.
And put the
spectrometer on the ground and go to sleep.
And start analyzing the soil.
That's right. Now, all night long, the spectrometer will be pinging the soil with little alpha particles and collecting the resulting reflected particles, and that will tell us what the chemicals in the soil are. And that will be all stored on board Sojourner. Now, she has some batteries that she can do this at night because she has primary batteries. That's like flashlight batteries, not rechargeable. And those batteries allow her to work at night because there's not a lot of power drain for that little instrument. The computer will have to stay awake because the computer gets the data. And in the morning, the rover will send the data to the lander and we'll be able to see it here on the ground.
How many scientists do you expect will be crammed into that small room at Building 230, reaching for that data as it pours out on that first downlink?
Well, actually, the alpha proton X-ray spectrometer team is very small.
Is it?
Oh, there's only 2 or 3 of them because it's a very inexpensive instrument. It was two-thirds of it was provided by Germany for free to us, and the other part of it was provided by the University of Chicago. So there's only a few experimenters, but the whole science team will be very, very interested in the results because they match that up with the mineralogy, the colors that they get, and the spectra that they get from the lander camera. And it's all going to fit together into really telling us about Mars.
Will they get some very basic knowledge or some basic information right off the bat, or is it going to take them time to analyze what comes back?
It depends. I think if the signatures are very strong, for instance, if there were a lot of iron, which we expect to be in the soil, they should get a very strong iron spectrum. But there may be just sort of trace elements that they may have to massage the data a lot to get it out. If there's something very tiny, they wouldn't be able to see it. I mean, if there's only a tiny amount, because it's just not that strong an instrument. But they'll certainly be able to confirm whether the dirt on Mars is anything like the dirt on Earth, for instance, or whether it's quite different.
Who makes the decision, or has it already been made since, last question, who's made the decision on what rock to go to tomorrow?
Well, the scientists as a whole, they have a process. The imaging team gets to select the rock, and the alpha proton X-ray spectrometer team has an input, and they basically kind of vote, and then one scientist goes and represents to the rover driver, this is the rock we want. And then if the rover driver says you can get to that rock, then that's the rock. The rover driver may veto it and say, look, that's too hard and too dangerous. But I think we can get to that knobby rock right there.
You certainly can. Well, continuing excitement here at the Jet Propulsion Laboratory. Hasn't been a dull moment in a couple of days, and we certainly expect that the excitement will continue. But again here, within the last few minutes, at least on Earth time, it happened a few minutes earlier than that, history has been made. The first autonomous vehicle that humankind has put on another world is safely on that world, on Mars. This is John Zarella reporting live
from the Jet Propulsion Laboratory in Pasadena, California.
Yes, John, it indeed has been exciting, and certainly history has been made. Watching all of this unfold live, John, on CNN, along with the scientists who have worked so hard on this. I know this was exciting for you as well. And, John, there is a news conference coming up at 2:30, right?
Yes, there will be a news conference coming up in about 20 minutes, at which point I don't know what they can add to the excitement we've already seen here. But certainly there will be a news conference, and they will explain to us the images and where the Sojourner is and what they plan to do tomorrow. But basically it's time to say goodnight to Sojourner and put her to bed for the evening. The vehicle has performed admirably, as the team has here. And again, as Donna Shirley said, they wait till tomorrow, and then they get that first data back, and then they send Sojourner off to examine the rocks.
All right, John, and we hope to bring that news conference to everyone live. Thank you, John Zarella in Pasadena. And that concludes our coverage for now. And CNN domestic viewers will be rejoining Larry King live, and CNN international viewers, stay tuned. World News is coming your way next.
A few minutes ago, within the last 15 or 20 minutes, you could hear the cheers just rising up here at the Jet Propulsion Laboratory from Building 230 and the surrounding buildings here as the first images came back from Mars showing the Sojourner robotic vehicle actually on the surface of Mars. And there is one of the enhanced pictures. You can see it there. Sojourner on Mars, again, history made, the first time an autonomous vehicle has taken some small steps across the surface of another planet. And joining me to discuss this is a woman who is perhaps synonymous with Mars rovers, Donna Shirley, the head of exploration, Mars exploration here at the Jet Propulsion Laboratory. Donna, this had to be one spectacular moment for you.
Absolutely. This was just the culmination of 30 years of since I've been at JPL for 30 years, I've been wanting to work on Mars, and here we are. We're on the surface of Mars. And there's Sojourner sitting on Mars. These are the raw pictures that first came back. These are compressed, so they're not real good quality.
There it is off in the distance
there it is,
already.
Off in the distance. Now, oh, here's the movie. There's the movie. It just went down the ramp. Now watch this. 1, 2, 3, bang, onto the surface.
I understand we have...
see the ramp moving around when the rover...
As the rover went down.
So as the rover gets onto the ramp, it actually compresses the ramp down, and off she goes onto the surface.
I understand Howard Eisen is on the phone as well and can hear us talking. And Howard, pretty exciting, heady time for you. You designed... your team designed that ramp and much of the engineering that went into getting Sojourner where it is now on the surface.
That's right, John, and we are as ecstatic as can be. You've probably seen the shots of us all clapping and hugging each other and everything else.
I saw you high-fiving. Donna and I were standing here watching you high-fiving with some of your compatriots there.
It's been absolutely fantastic. That image of the rover on the ground is something we've all been waiting for 3 years, for some of us 10 years, and like Donna said, she's been waiting 30.
Donna, what do you weren't there. Unfortunately, you didn't get to share that moment because you are out here with us giving the world your time, which we appreciate.
We're all on our way down there to hug her now.
Well, I get a lot of hugs later. That's okay. I can have delayed hugs.
Delayed hugs, Howard. What was the emotion going through your mind, Howard, as this was unfolding?
Well, it's a strange thing. We actually got the images of the rover on the ground before we got any telemetry saying that we were moving. So we were all staring at the same TV screen you were staring at, just hoping to see those images. And when we did, it was just unbelievable.
We've been seeing, Don and I are watching here, and we're seeing the movie where you can actually see the ramp moving as the rover crawls off and puts the weight on the ramp and pushes it down.
That's right. In your image there, the left side of the ramp is actually sitting a little bit on some airbag material. And so as the rover comes down, that material is compressing and the ramp is moving a little bit. The ramp is very, very light and only tied down at the lander end.
But earlier in the evening, we had seen some of your colleagues working up in the sandbox to make sure, I assume, that all would be okay as the rover went down. So you expected this, didn't you?
Yeah, we felt very good about it, but we figured one more test certainly couldn't hurt if we've come this far.
And again, congratulations to you and your team. And I assume Donna's waiting here for you to come out and give her that big hug, you and the rest of them. But go and enjoy. I imagine tonight will be a night for a great deal of relaxation and...
well, not really.
We have a lot of work to do.
That's right. There's a lot of work to do. They have to plan the next day's activities, and when the scientists pick their rock, they come in, and the rover team has to plan how to go get it.
Howard, we want to thank you for joining us.
Thank you, John.
And Donna, this has been just an incredible night and 2 incredible days. About as heady a 2 days as you probably could have hoped for.
Yes.
How does it make you feel?
Makes me feel great. I feel terrific. I mean, this has been the culmination of a dream, and it's just wonderful. Absolutely wonderful.
Donna Shiro, there really isn't much else to say.
No,
Thank you so very much. We can hear the team now. They're coming. Many of the members of the team are coming over here right now.
Yay!
And they're cheering. So, Leon, this is, you can't really say much more. History has been made here at the Jet Propulsion Laboratory. The team is actually going by us here.
Right.
And Brian Muirhead is there, and Wes
Norm Haynes,
Huntress,
my boss,
the
Wes
Associate
Huntress.
Administrator for Space Exploration. And you can see this. There's some fabulous photos. I'll steal them.
No, you don't get that.
From Wes Huntress.
There's your baby.
There's the first actual photos taken.
I want one.
So, Leon, we're going to toss it back to you now. This is really certainly an exciting event in the history of U.S. space exploration.
All right, Al.
Leon.
Thank you, John. History in the making with some rather excitable scientists there.
The following is CNN's coverage of a live event.
We return now to the developing story of the Mars Pathfinder mission. There is a press conference being held now by NASA scientists. We expect to join that right now. As you can see, some rather excited scientists. They, a few moments ago, celebrated the arrival of the Sojourner robot on the surface of planet Mars. Let's listen in to what they're saying now.
And we have the flight team here, and Richard Cook, the mission manager. And Dr. Jake Matijevich, the rover manager. Let's start with some comments from Richard.
Actually, we have the men and women of the Mars Pathfinder flight team. Yeah. There you go. Okay, well, I'm not sure this day has been exciting enough for all of you guys, but I think it has been for all of us. I didn't think we could top yesterday, but it certainly feels that way today. It's been just a great day. The spacecraft is doing wonderful. The rover is on the surface of Mars. We got some great images back and continue to get them back at just a tremendous rate. I know all the scientists are in heaven at this point. So we're really looking forward to getting it on with the rest of the mission, getting the rover out there, looking at some of those rocks, and that'll be what we're going to do in the following days. So with that, I'll let Jake tell you about the rover.
Yeah. Well, it's my distinct pleasure to present to you the first rover on the surface of Mars. The images that you've seen today show a completely deployed rover that has driven down a perfectly deployed ramp and gotten to the surface of Mars, making its first tracks in the soil of this new planet. And to us, you know, it's opening a new era. opening a new era of exploration, which we, as in the framework of the faster, better, cheaper, actually starts tonight as we plan our first activity tomorrow on the surface of Mars. So as you've seen this rowdy bunch over here, these are the real heroes of the day who worked really since last night to solve an incredible set of problems, worked through a number of issues to get us back on our nominal mission. And all I have to say is that's the group that's going to give you the best results that we could possibly do over the next course of the next several days, and hopefully even longer than that on the surface of Mars. So at some point, you guys are going to have to meet them all, but in particular, you have to meet a few of our rover team, particularly those who are shown wearing insignias of this kind. If you've noticed, in addition to the one image that we showed here of our end-of-day position on the surface of Mars, there's also a nice little movie that one of our engineers has put together, actually showing the rover deploying down the ramp. And if we can have that movie cued, please, for display here. Yeah. Oh. Almost did it, almost did it. Okay, that's actually a movie of our esteemed team. There it is. Okay. As you can see, as the rover drives down that ramp, it moves it quite a bit as it deflects it going down. Finally, it ends up deflecting it for the last time, the ramp bouncing back up again as it deploys onto the surface of Mars. Just a terrific set of pictures and a terrific feeling watching these images come down today. So, so we're on to our next day's activity later tonight, and I think that's all I need to say at this point.
Okay. Well, it's been a long and wonderful day, and I know we need to let you get back to work or to some well-deserved rest in some cases, but let's try to get in a few questions here just to wrap things up. Let's see, let's start down here with Matt from AP.
Matt Crenson from the Associated Press. How long does that movie take to transpire in real time?
It's actually, the actual deployment down the ramp takes only about 4 minutes total. It's the rover is actually driving in a move fashion in which it's driving its maximum speed essentially down a 1 meter ramp. So.
Just saw from Justin Mackey, our rover director over there, our film director over there, that it was about 2 minutes. Frames were spaced over the course of about 2 minutes.
So.
Okay, Kelly?
Can you give us a time of when all 6 wheels were on the ground?
We actually get a scat time down for some telemetry? I don't know.
I think so.
We'll have to get back to you. I'm sorry. I'm not sure of the exact time.
Shall we start a pool?
Seth Borenstein, Orlando Sentinel. Since you went down the back, are you going to use what are your first 2 or 3 targets, and how far off the ramp are you? 5, 6 inches, or what?
The actual move is a total of 2.2 meters from the edge of from the center of the pedal down to the end of the ramp. As you can see, it's approximately about 3/4 of a wheel diameter, which is on the order of about 10 centimeters off the ramp.
William Boyer for Space News. Do you have confirmation that you're doing the soil sampling yet?
I don't know if we actually got that engineering telemetry down. The downlink closed rather quickly after these images were sent. There's nothing to tell us differently that the APXS wasn't properly deployed out on the surface and has already begun taking the first spectra of soil at the rear of the ramp. Trying to answer your question a bit here, I missed part of it. The next kinds of targets that we're looking to perform in our experiment sequence include performing a soil mechanics experiment in that general area to get our first measurements of the interaction of the wheels and mobility system with the surface of Mars. And that rock, if you have been following the activities and discussions over the last couple of days, is of high interest to our geology team. So that may well be our first target for an APXS. Okay.
Okay, David Chandler.
David Chandler from the Boston Globe. Can I ask you to do a little 30-second science here? You've got some tracks on the surface already. Is there anything at all you can tell now about the consistency of that soil from what you see?
I think I'll ask our soil mechanics team tomorrow, after they've come down a little bit, to do a little more careful analysis. It's our first measurement of soil mechanics, literally on the surface. But there's other things we plan on doing to expand on that data set. Let's put it that way. So we may have an answer for you in another couple days.
Okay, let's see. I'll take one in back here, and then see if we can get to Todd there.
Yeah, Jeffrey Kay from Public Television. When do you expect to receive the first images from the rover itself, and also the images from the camera from the lander at its fully extended position?
We got our first image from the rover in part of this downlink. This is actually an image we take of the ramp. We're on the pedal at this point, and we're just looking forward to taking an image down that deployed ramp. So that's one of them that we've taken. There's one also of the rear. I'm not sure that has actually come down. There'll be some other images taken from the rover tomorrow of up the ramp that we just descended, hopefully making a rather nice photo shoot for you to have in your newspapers Monday at the latest. I believe the deployment is meant to occur today.
Yeah, we actually activated the sequence which will deploy the imp mast in about 2 hours from now. And so actually first thing in the morning we will acquire some images from the deployed position and return them down probably in that first transmit session that we get in the morning.
Todd?
Todd Halverson, Florida Today. I was wondering if you could just walk us through what you anticipate the activities for the day will be tomorrow, and when they'll start Pacific time, and what they'll be doing, and when they'll end.
Maybe I could answer the latter part first. The confirmation of what we've done during the day is likely to occur around this same time tomorrow. Nominally after this, about an hour after this downlink closes, we have a series of our team members and scientists meeting in a set of, actually in a group setting to select the goals for tomorrow. I would prefer not to preempt their choice at this stage, but it will be either of these two issues, the notion of attempting to get some soil mechanics experiment, perhaps getting in position to take an APXS measurement of that rock. And it will be in some sequence like that, but I'd like to let that decision be made by the team as a whole.
As far as the lander transmit sessions, the first transmit session is likely to be around 3:30 or so tomorrow afternoon, and then we'll probably have one. I agree with Jake. It's a little bit hard to second guess what planning will go on tonight, but we'll probably have at least one additional transmit session about this time, maybe a little bit earlier tomorrow night. As far as activities that the lander will do, other activities, one of the big plans to do tomorrow is to take what we refer to as the monster pan, which is a set of higher resolution images in multiple colors that are in stereo that we use to plan the future traverses of the rover. And so that'll be certainly a high priority to acquire that. We're likely to also increase our data rate up to about probably 6,300 bits per second, in which case we're expecting to get just a tremendous amount of data down as a result of doing that.
When does the monster come down?
It comes down over the course of several days because it's, like I said, in multiple filters, but significant parts of it should come down tomorrow.
Okay, let's see, more local questions. I guess if that's about it, we'll wrap things up. I wanted to make one brief announcement. JPL's web servers have been absolutely inundated with public hits, as you can imagine, and the webmasters asked me to pass on an address that they'd like to recommend for the general public to use. If you find a hard time getting into JPL, the best server to try, I think, is being shown on the screens. It's http://mpf for Mars Pathfinder, www.jpl.nasa.gov. And this is a high-performance system that Silicon Graphics has arranged for, and I understand it should offer a good bet at pulling up the page. And with that, I guess we'll call it an evening, and hope you stay with us for a great mission.
Well, you've been watching a live press conference by NASA scientists at the Jet Propulsion Laboratory in Pasadena, California. Some very excited team members celebrated the successful touchdown of the Sojourner robot on the surface of Mars. It sent back pictures as it rolled down the ramp from the Pathfinder spacecraft onto the planet's surface. As its 6 wheels made contact, history was made. The Sojourner will begin gathering geological samples from Mars, which will last around 7 days. And the scientists were promising that they'll have some more exciting pictures tomorrow. Well, we'll have more on that story and the rest of the Earth News at the top of the hour. But now we're going to join World Sport in Progress.
This has been a CNN Live event.